I think that the broad situation with AI is that they're currently successfully scaling them more and more powerful. We're not quite sure how long that process is going to continue using the current technology, and part of the reason we're not sure is that nobody understands what actually goes on inside a modern AI. We can look inside the computer, of course, but we see giant arrays of floating point numbers, and people are barely beginning to understand what's going on in there, and we do not quite understand where the power comes from. Chess did not stop playing when it got to human level. Go did not stop playing by the human level. They are past only training the AIs on imitations of human output and have moved on to training it on what works to solve problems, and you can just continue that process past the point where the problems are of human difficulty. So we're on course to get something smarter than us, whose innards we don't understand, which we cannot very well control, and this probably ends quite poorly.
We're making the statement that the one thing we think we know about the AIs is that they have been successfully trained to optimize their achievement of purposes. That's an assumption which is not totally obvious to me. I agree that as you give sort of all you're specifying is sort of play chess or whatever else, so you're specifying some big, what we think of as an objective. The details of what's happening inside, there will be aspects of that we are not in any way able to foresee, predict, whatever else. So if we took apart that mechanism and we say, is this mechanism doing what we expect here? It won't be. There'll be plenty of things where it's doing what it chooses to do, or because that particular training run gave this particular result or whatever else. To me, I'm not convinced yet. There are interesting questions to try to answer, which people should try and answer. I mean, you make it sound like it's urgent, the people are coming off the ships, and you might be right.
MLST is proudly sponsored by 2 for AI Labs. They're based in Zurich, they're doing monthly meetups, and they are hiring cracked ML research engineers to work on ARC and to make progress towards AGI. Go and apply now, 2forlabs.ai.
What matters is the strong desire to solve the challenge and this technical capability. Usually the type of people we tend to find have computer science backgrounds.
Gentlemen, it's an absolute honor to have you both on MLST. Thank you so much for joining us today. We're going to have a discussion all about AI existential risk. And Eliezer, first, if you wouldn't mind, could you just spend about 5 minutes talking about how much of a risk is AI to humanity?
I think the term risk is understating it. If there were an asteroid straight on course for Earth, we wouldn't call that asteroid risk. We'd call that impending asteroid ruin or something like that. And I think that the broad situation with AI is that they're currently successfully scaling them more and more powerful. We're not quite sure how long that process is going to continue using the current technology, and part of the reason we're not sure is that nobody understands what actually goes on inside a modern AI. We can look inside the computer, of course, but we see giant arrays of floating point numbers, and people are barely beginning to understand what's going on in there, and we do not quite understand where the power comes from. By great efforts, you can look in the previous generation of the technology. I don't know if anybody's tried it with the current generation, and see it's currently thinking about the Eiffel Tower, or this is like the location where it stores the fact that the Eiffel Tower is in France, and we can move it to Rome by poking at the numbers, which is, pretty impressive. We can't do that with a human brain. But the basic question of sort of like what's going on in there, how are they doing the impressive new parts, that's all unknown. If the technology continues to scale, which it may or may not, nobody knows, it at some points gets smarter than us, as smart as us, and then smarter than us. There's no particular barrier that I know of, or that I know of any principled reason to believe in at the human level. Chess did not stop playing when it got to human level. Go did not stop playing by the human level. They are past only training the AIs on imitations of human output and have moved on to training it on what works to solve problems, and you can just continue that process past the point where the problems are of human difficulty. So we're on course to get something smarter than us, whose innards we don't understand, which we cannot very well control. And this probably ends quite poorly. There's a lot of mistaken reasons to believe that it automatically ends well. It's various people have different mistaken reasons to believe it automatically ends well. There's I don't know if any of you, I don't know if you, the viewer, I don't know if any of the other people here have this particular mass apprehension, but people ask, why wouldn't they just trade with us? They have heard of Ricardo's law of comparative advantage, a very important theorem in economics, which says that even if one country is more productive at producing every kind of good than some other country, they will still end up trading because of the relative differences in productivity. If it is easier for me to make hot dog buns than it is for me to make hot dogs, I will ship you hot dog buns and get back hot dogs. Or like, if compared to you, I'm at less of a disadvantage in making hot dog buns than I'm at a disadvantage in making of hot dogs. We will both benefit by shipping hot dog buns and hot dogs back and forth. This unfortunately assumes the absence of a third option, which is for B to be so much more powerful than A that they kill A and take all their stuff. There is not a theorem saying that the work produced by horses has to be worth more than the cost of feeding the horses. You can always benefit by trade, but you can sometimes benefit even more by killing people and taking their land. I wish that wasn't a possibility, but it is. And so there's all these reasons that people have for thinking that even if we don't understand AIs and can't control them very well, they could get much, much smarter than us and it could still end nicely. And I think these reasons are all mistaken. And so by default, this ends terribly. And I think that's my 5 minutes.
I mean, I guess it's interesting. I mean, my first statement is this notion of kind of an index of smartness is something that I kind of don't believe in. I mean, one thing that's sort of my personal experience for the last, 40-something years is I already know the computers are smarter than me. I mean, it's kind of, I started doing these experiments on kind of what's out there in the computational universe years ago, just looking at very tiny, simple programs where, you might have thought this is a really simple program. Surely I'm smart enough to figure out what this does, but no one's not. I mean, even last night, I was doing some experiments where I was pretty sure I knew what was going to happen, but no, the computational animal was smarter than I was, and it did things I didn't expect. So I've kind of, I guess my default point of view is I know the computational universe contains many things that I can't readily foresee, just as the physical universe contains many things I can't readily foresee. So the question then is, one thing one could take the point of view, there's this kind of single index of smartness. I mean, I think people, in the 1930s, people wanted to invent kind of an index of general intelligence. They called it G for humans, which I've never really believed in, because I've never really believed that there are some things I'm pretty good at doing where I feel I'm pretty smart. There are other things where I know I'm pretty dumb. And it's kind of it's not really a sort of single index. I guess the thing that I wonder about in the kind of the AIs will be smarter than we are is to dig into what that really means. And, I think the first thing to say is, that, the big limitation to whatever you might think smartness is this phenomenon that I call computational irreducibility. The idea that if you have a computational system, the question is, can you jump ahead? We are used to the idea from lots of exact science over the last few hundred years that, the planets do what they do according to these laws of motion, but we can find a formula that lets us just work out what will happen in the end without having to go through all the steps. One of the things that's sort of a foundational fact that we can talk about, where it comes from, but, it's kind of the whole idea of computation leads to this fact that there are many computations that one can set up where to know what will happen, you really have to just go through all the steps and see what will happen. You can't kind of jump ahead. Now, a lot of what we've achieved in science and mathematics is to find little pockets of computational reducibility that allow us to jump ahead in some place or another. That's what most of our inventions have to do with, taking what is out there in the sort of computationally irreducible world and finding some particular place where we can jump ahead and where we can kind of foresee what's going to happen and make use of those things. So, I mean, I kind of think the first thing to realize, I think, is that, smart as one could be, so to speak, there's no way to get out of computational irreducibility. And in a sense, then what one's talking about is there are these pockets of reducibility. We find some. There are ones that we humans care about. There are ones that our civilization depends on. There are lots of other pockets of reducibility that we haven't found, many of which we probably don't care about in the current way that we are thinking about things. And, I see it, I don't see it as being this kind of linear, oh, this thing is now smarter than us, so doom, so to speak. I think that it is, and as I say, my own personal experience has been, I'm completely used to the idea that computers are smarter than I am. And, while, there's sort of the question of, are those computers connected to everything that runs my life, so to speak? That's a different issue. But in terms of the raw experience of, are the computers smarter than I am? Well, I already know that they are. Now, I think the other thing to say is, can the computers get smarter than we are in some sense in every dimension where we humans are used to doing things? That's a different issue, but I think that's a different issue from and then there's the question of sort of what does it mean if we live in a world where there's lots of things going on that are sort of smarter than we are in some definition of smartness? Well, one point to realize is the natural world is already an example of such a thing. I mean, the natural world is full of computations that go far beyond the computations that we do in our brains. And, how do we manage to coexist with the natural world? Well, we found these particular niches where, it doesn't matter that it rains a lot because we build houses and so on. We found these ways to coexist with the natural world that seem to let us lead the lives we want to lead. There are things we can't do because our physiology, our biology doesn't let us go there, but we seem to be able to live contented lives, even though we can't, go to the bottom of the ocean, without, having some complicated, piece of technology and so on. So, I mean, I think that would be my initial kind of thinking about sort of why I'm not as worried about the moment when, the intelligence of the machine goes from, 150 to 160 to 200 to 300, whatever that might mean. I mean, galloping through the Raven's progressive matrices at a rapid clip is not, again, from my point of view, it's kind of it's already happened that there are many things in that, that computation can do that are beyond what I can do with my sort of unaided mind, so to speak. So I'm curious, I mean, do you see the issue as being kind of a more of we put the AIs in charge of our, air traffic control and our, medical devices and our this and that and the other, and so at the sort of actuation layer, things kind of go wrong? Or do you see it? I mean, the thing, again, that I have a bit of a hard time with is it feels very anthropomorphic to talk about kind of, the AI wants to do this. The AI is, wants to trade with us or not, or whatever. That, I could talk about the natural world in the same way. Does the weather want to give us a good time or not? I don't even know what that means.
Could I just segue as well? Eliezer, I understood your point as there's a powerful force which is going to push us out of equilibrium. And I think Stephen is making the argument that we are in an equilibrium now. Is that fair?
That didn't sound fair to me.
Okay, so I understood that Stephen was making the argument that there are these countervailing forces that prevent significant deviations.
No, I don't think that's what I was saying. I mean, I'm not claiming that the world won't change. Okay, I'm simply saying the idea that it's kind of, game over because suddenly the IQ crosses 300 or something. I don't believe in that.
I think we probably both agree that IQ 300 is not meaningful.
Right. Okay. I'm not surprised we both agree about that. But no, the point that I'm making is that this idea that somehow the AI gets smart enough to be able to do everything, I don't believe in that. I mean, I think there's this sort of computational irreducibility limit that, great neural net or not, that's just a fundamental kind of formal limit that we don't get around.
So I first want to try to sort of repeat back your summary. And your summary is like, because we cannot predict a thing, it shows we're not smarter than that thing. And even in a sense that it's smarter than us, because it's something that it knows, which is its own output, that we cannot predict ahead of it. Does that sound like a correct summary of your?
Well, part of it. I mean, the problem with a lot of these things is we get a word like smart, and then we don't, we kind of think we know what it means, but then it kind of slithers around on us. And I think that's part of, but I would say that, what I'm saying is merely that if you say, I want a system that can solve every problem, will I get to the point where I have an AI that can just slam dunk solve every problem? I'm saying
No.
that's not going to happen.
No. And in particular, it's entirely possible that if you pick a sufficiently strong quantum proof one-way hash and hash something and throw away the key, that nothing, nothing at any point in the arbitrarily far future, even if it has consumed entire galaxies to use as computing power, will ever be able to find the input that you fed to that one-way hash. So in this sense, universal problem solving is probably not on the table, as far as we know, given the present laws of physics. But, the invading Europeans and invading North America did not need to be able to solve every problem to solve more problems than the Native Americans and mostly wipe them out.
Yep, that's true.
A fire doesn't need to be able to burn neon or other noble gases in order to be able to burn you personally. It doesn't have to be universal, and you don't even need to be able to define exactly what fire is to die in a forest fire. People have probably died in fires a long time before they worked out the concept of combustion and chemical rearrangements with oxygen that had ended up in states of lower potential energy, which released that as kinetic energy, which looks like heat, which is what burns you. People didn't know that, and they still died in forest fires. And I can try to define what's in intelligence, but before I do that, I do want to point out that being unable to define something is not bulletproof armor.
For sure. But I think the question is, it seems like the argument that you're making, which may not be correct, is, I mean, I may not be correctly representing it, is, there will be AI is advancing rapidly. We can talk about, what we know about how AIs work inside and the whole story of computational irreducibility and how it applies to that and why machine learning works. Those are interesting questions. It'd be fun to talk about those. But I think one of the issues is we don't know, just how effective, AIs are going to become. But we do know there is a limit to how effective they can become, because we know that there are, as you say, I wouldn't go as far as talking about, elaborate one-way hashes and things. There are much more straightforward kinds of things that you can't predict except by running the steps.
Particular cellular automata?
Yeah, for example.
Sure.
Right.
I think we agree on that.
Right.
Just to stipulate that part.
Yes, right. So I mean, okay. So then the question is, could it be the case that everything we humans care about can be done faster, better by AIs? Could it be that the things that are important for running the world, and that that there's sort of this, there's a question: could everything that humans do be done better than AIs? That's a different question from whether AIs can sort of do everything, can do things that we have no idea how to do. How to do.
I mean, even if there's one last remaining computational task that a human brain can do better than an AI, by like predicting the exact output of that particular brain, which you're sure not going to get without doing a bunch of intervening steps if you want it down very exactly, that is not necessarily protective against a bullet, right?
Sure.
Like there were
No,
problems that the
absolutely.
Native Americans could solve better than the Europeans who wiped them out.
Absolutely. There will be, just as, for example, the weather has ways to wipe us out. So, it's in any particular, I don't know, you can imagine some mega super storm that we don't completely understand, that, because we're talking about, again, things we don't completely understand. So I think we can as well say we don't know what's possible from the weather as we don't know what's possible from the AIs. And, I can imagine that there's some terrible thing that can happen. People imagine with respect to climate that that's going to wipe us out. Another thing that involves sort of lots of extrapolation about what's going to happen.
I mean, you can kill a lot of people without killing everyone. It is much harder for the weather to wipe out every last human on the face of the earth than it is for the weather to just kill a lot of people.
Fair enough.
And I think that total extermination is like much worse than just a lot of people dying, because you also lose posterity. You lose the meaning of history.
Right. Okay, so we could segue to a quite different topic, which is, in the history of life on Earth, there have been plenty of times when, if we were two stegosauruses talking about this, 100 million years ago, whenever stegosauruses were around, the stegosauruses would say, gosh, it would be terrible if we were wiped out, and if those pesky mammals that have just the one or two things that they can do better than us took over. And I'm curious about, your view of the ethics of that situation relative to.
This is a very different line of reasoning from let us define intelligence, the work done of prediction,
I
the work
agree.
done of steering. What does it mean to want something? Does a chess game does an AI chess player want to win chess? Well, it's definitely very good at winning chess, whether you say it wants to or not. Does it want to protect its pawns? I just want to remark on all of the places we could have maybe gone to and temporarily bookmark.
Let's put that aside for a bit later. But let's talk about
stegosauruses. Yeah.
We'll put the stegosauruses in their pen for a little while longer, and we'll come back to the stegosauruses later.
Oh, we'll come back to the stegosauruses later. Okay, I'm up for that.
Unless you have some quick comment about the stegosauruses.
Very broadly, that the trouble with looking at the change from stegosauruses to humans and determining and viewing a trend of things getting better and better and turning out pretty much okay is that as humans, we're drawing an arrow around the target. If we got wiped out and replaced by stegosauruses, and the stegosauruses had, didn't care about each other very much. They grew up in different evolutionary social circumstances. If we were wiped out and replaced by insects, maybe the hives of, sapient insects just never care very much about other hives. They just don't they don't end up caring very much about sapient life at all. That would be a grand tragedy. It's not at all clear to me that you can wipe out humanity and replace it by arbitrary stuff and everything just gets better as a result.
I don't know what better means. I mean, better is a very human concept.
Well, that's the whole, there you have it. And yet, if we're going to decide whether we want to voluntarily wipe ourselves out and replace ourselves with, sapient ants, we need to ask ourselves whether that's better or not. We have no other way of making that decision.
I think it's not a question necessarily better. It's like we're humans and we're happy to be around, and we kind of want us to continue, because that's, we're kind of the in-charge critters around here. And it's kind of like, that's, let's stay in charge. Why would we give it up to something? And we might have some argument that, oh, of course, these other ones that we might give it up to are worse than us. But, in the end, it's like we're here and we kind of like being here. So we'd like that to continue, I think, at least.
That's not what I'm fighting for. I want there to be sapient life that cares about other sapient life, that doesn't just discover things about the universe, but appreciates those discoveries, that looks out at the universe with wonder and curiosity rather than mere expected value calculations. I want it to have fun. I want it to be conscious. I'm worried that these things get lost. And if you say that, if you want life to be conscious, if you want there to be consciousness in the humans, consciousness in the universe, that's just your preference, Eliezer, then we might need to have a long conversation about what alternate state of meta-ethical affairs you thought might have obtained other than that, to be disappointed at the absence of or to critique the absence of. But mostly I'm like, yeah, I'm the one who says I'd rather the universe be filled with consciousness than mostly unconscious. And, yeah, I'll own that.
This whole question about, consciousness, it's like, I'm pretty sure that I have some consciousness. I have this, thread of experience. I'm experiencing things. As far as I'm concerned, you're a bunch of pixels on the screen. I have no idea, what's going on inside you. It is an extrapolation that you are conscious. The only thing that I can, readily kind of from experience believe is that I'm conscious. And, when it comes to even an AI, is this thing, quotes, conscious, or is it merely a bag of bits? I mean, in other words, and with an AI, we can, with some effort, go and look at all the bags of bits. With human brains, we can't yet do that. Presumably, eventually, we will be able to do that. And once I can see all those neuron firings in your brain, how will I think about the consciousness in your brain? And how do I even know what's going on beyond from what I can experience inside myself?
Well, I infer that you're conscious based on knowing that I'm conscious and thinking that probably something pretty similar is going on inside you to me because we have similar great-great-great-great-great-great-great-great-grandparents. We are built on like basically the same engine plan. I haven't actually administered an MRI to you, but I would guess that you've got like pretty much the same brain areas I do, cerebellum, cerebral cortex, even without knowing exactly which features of the brain are executing the algorithm that I experience from the inside as my being conscious. I can guess that you probably have a pretty similar algorithm, um, based on you claiming to me that you're conscious and all that.
Right. I mean, it's an extrapolation.
Such a similar design.
Right. It's a reasonable, piece of scientific induction extrapolation. But what I'm curious about is if you say the only thing that can be conscious is something that has that exact same design.
Oh no,
then
I don't say that.
Okay, so So where's the boundary?
So it's not so much that I'm worried that machines cannot be conscious as I'm worried that the particular uncontrolled superintelligences we end up making are not going to value consciousness all that much, which means that they're not going to produce very much of it. Like maybe consciousness is the most efficient way to run some paperclip making algorithm, but if you don't value consciousness for your own sake, then the little bits of consciousness that are supervising the paperclip making algorithms are, not going to be as much consciousness as we could have made of the universe. And if they don't value fun, they're probably not having fun either. They're just being efficient because they didn't end up valuing fun. That's the general class of nightmare scenario that I'm worried about.
I mean, I really wonder, my computer, when it runs and does all these searches and it finds these cool, cellular automaton patterns or whatever else, I wonder if it's having fun. I bet
at 99 to 1 against. I don't know everything that there is to know about this, but it seems to me that when I stare at the machinery of having fun, there are gears and wheels there that are not built into a pocket calculator, that are not built into a simple Python program searching through a list of cellular automata. Like,
I wouldn't
stuff
use a Python
happens.
Program. That's very low level. Sometimes things like sort of people say, the one thread, the one sort of shred that we have that machines will never have is some kind of emotional response to things, which, I think that's a very weak concept, because I think emotions are a very chemically based kind of thing that's actually very coarse compared to a lot of the other things that go on in brains.
Yeah, it's not that I think that machines can't have emotions. I suspect that Claude 3.5.1 Sonnet or GPT 01, if they have anything resembling emotions, they're not our emotions. There's like something inside it that was trained to imitate emotions, but if it has emotions, my guess, nobody knows, is that they would be more appropriate to like carrying out the job of being the actor who plays the part of a human who has emotions and not actually the human emotions themselves. And it's not fundamental to transistors. It's just like what I would guess would happen given the particular way we put these transistors together.
So what you value in the universe and in humanity is a certain set of attributes that have to do with the ability to have fun, the meaning of consciousness and so on. And it is, as I'm understanding it, you think those are sort of the most valuable things that maybe we as a civilization, we as a species have produced. And you think it is our responsibility, if I'm understanding correctly, you think it's our responsibility to kind of preserve these things in the universe. Is that a fair assessment?
I could quibble with the exact wordings, but sure. The light of consciousness, the light of fun, the light of caring, to preserve these things into the galaxies is the most important thing we have to do.
Because you feel that's sort of our big achievement, and it's kind of like it's now our responsibility to, I don't know quite to what, but it's somehow our intrinsic responsibility to preserve these valuable things.
I mean, I think we got handed these things on a silver platter, but that, not, or, like maybe a kind of rusty iron platter that we had to shine and clean up a whole lot, but, still on a platter from natural selection and even from cultural processes of development that nobody really saw coming at the time. There were, few people did them on purpose. Somebody did at some point say of slavery, it is time that some person should see these calamities to their end. Not all moral progress was accidental. But, still, like our basic situation of being humanity, of being here on this planet, of having the opportunity to colonize the galaxy, we fought for this a little bit, but it was ultimately handed to us on a platter. And I don't say that it's like written down on a stone tablet anywhere in the universe or laws of physics that we must bring this to the galaxy. I just say, I want to do it. That's what I think is the right thing to do.
Okay. So, I mean, this is, I don't necessarily disagree with you, but it's worth understanding that this is a feeling that you have. This is not something where, as you say, there's no law of physics that says this is the destiny of the universe or anything. This is on this particular planet, through this particular process of natural selection of biology and culture and so on, we got to this point. We're really proud of this. Let's try and preserve it. I mean, is that
the fact that I want to steer the universe there isn't a fact about the whole universe. It's mostly a fact about me.
Sure.
And a whole lot of other people, to be clear.
Yeah,
but,
right.
This is not like 2 + 2 = 4. This is not, like water is 2 hydrogen atoms and an oxygen atom. This is, where I steer the universe being the sort of thing that I am.
I agree with you. I think one of the things to realize is that if you just let raw computation do what it can do, much of what it will do are things that we humans just don't care about. Just like a lot of what happens in nature are things that we humans don't care about. We've never managed to, sort of take those things from nature and make them into technology, have those things be things that we appreciate as beautiful or whatever else. They're just random things that happen in nature that we don't particularly care about. And most of what a computational system could do is things that are, away from the things that we care about in kind of the computational universe. Now, so many of those things are just things that will just happen, just like they happen in nature. We will kind of shrug our shoulders and say, okay, that's a thing. A lot of what probably happens inside neural nets right now are things where, in fact, I have pretty good evidence of this. They're things which are sort of complicated computational processes where they don't really produce anything that is something that we can recognize or that we care about. They're just things that are happening computationally. And so I think that your concern is that some of those things that might happen or that the AIs might do might be things that collide with what you see as being our sort of responsibility and our, proudest artifact in a sense, that somehow there will be a collision of what is, what AIs, computational systems, whatever, can do, and the thing that you think we as humans sort of have most proudly produced. Is that a fair assessment?
Yes, if it that works out to they kill us and then go on to do nothing very much interesting or worthwhile with the galaxies that they colonize. Like, is that also a fair way of describing all of that?
Well, I don't know. I think that, this question of, okay, there are several different pieces to this. I mean, I think, look, the first question is the practical question, 5 years from now, 10 years from now, will we be able to have this conversation anymore? Or will we be, will we be dead, replaced by bits that are doing what you might think of as meaningless things, but bits, will it be the case that it's as if an asteroid had hit the Earth and all life was wiped out or whatever else? That, that's the,
if an asteroid hits Earth, all the atoms in it go on doing their little atomic things, the little electron cloud, I want to say circles the nucleus, but of course it doesn't really, blah, blah, quantum. But, the thing that quantum physicists describe to the lay audiences as, circling the electron, circling the nucleus, it goes on doing that. Maybe some amount of fusion occurs if an asteroid hits hard enough, some amount of fission and fusion. But, by and large, the atoms go on doing their atomic things, but they're not morally valent things. They're not important things. They're not worthwhile things. The Earth, the universe gets a little darker every time a bullet gets fired into somebody's head or they die of old age, even though the atoms are still doing their atom things.
Right. Okay. So this is, I mean, to me, that's a curiously, I mean, viscerally, I agree with you. Scientifically, I have a bit of a hard time. I mean, in a sense that feels like a very kind of spiritual kind of statement, which is not necessarily bad, but it's just worth understanding what kind of a thing it is. I mean, it is saying that there's something very kind of sacred about these attributes of humans, and that we have perhaps even a higher purpose to, which we don't really know where it comes from. Perhaps we can't to somehow preserve and but there's a much more practical thing. I mean, as humans who like doing what we're doing, it would be nice if we could go on doing that without all being killed by AIs. So I think
I don't see any distinction between these, like there's nothing more scientific about saying, I'm a human, I like to keep on doing what I'm doing. And like, I'm a human, I'd like to fill the universe with the light of consciousness, even if that consciousness isn't human, so long as it cares and is having fun.
Yeah, no, I agree. Like, those are both statements about how humans feel about things. But it's worth remembering.
They're not false. They're not unscientific. There is not a truth of science that contradicts our caring.
No, absolutely not. It's like, ethics is not a scientific field. It's about how we humans feel about things, and we humans could feel this way, we could feel that way. It's to do with the nature of us as humans, and we could scientize those statements by saying, let's do an fMRI and notice, why do you say that? Oh, your such and such lobe lights up. But I don't think that's a particularly useful thing to say. I mean, I think it is a fair statement that this is, it is a thing that we can capture, that humans feel that this should happen or not happen, whatever else. But I guess that there's one question is, what's the right thing to have happen? I don't think there's any abstract way to answer that. I think it's a question of how we humans feel about it. And I think you and I seem to feel, I know I feel, that, preserving kind of what humans do is a good thing. I can imagine even humans who say, no, the planet is much more important than the humans, for example. Anything the humans do on the planet that messes up the planet, get rid of the humans. We just want the planet is more important than the humans.
I think that in terms of prospects of human existence I'd like to preserve, I would not include mosquitoes. Can just like get rid of all the mosquitoes. I think the planet would be fine. I think we'd be fine. I would, if I could, get rid of this whole aging business that humans do. This was more controversial. It would actually change things if that happened. And some of the changes might not even be positive, but my guess is that they would be quite positive on net. And I'd be in favor of, if this were a thing you could do with a limited AI that wasn't going to wipe out humanity, and you could know that, and you weren't taking any extra risk by doing that, I'd say, use AlphaFold 5 to solve as many aging-related problems as you can. And some people would hate that. And there's the question of, is one of us making a mistake? Is it the case that if you take me and the person who wants to preserve aging, who wants humans to keep getting older and die, that you put us both opposite each other, and like one at a time, you just tell us all the facts about the way the universe actually is. You just expose us to all the arguments that exist to be considered about this, that any moral philosopher could invent in, some sort of random order. Do we converge, or do we just want different things? And it's not clear to me that, this is an instance of conflict versus mistake. It could be that the people who believe that aging ought to be preserved forever, that there are things you could tell them about what would happen if we cured aging that would change their minds. It could be that there's true things about what would happen if you cured aging that you could tell me. That would change my mind. You could show me some like dystopian world of 300 years in the future, which is like just being ruled by Vladimir Putin forever and ever, and nobody's having fun, and I could be like, yeah, okay, that was worse. So it's not clear to me that we need to say that they and I care about different things. We might, but it's not sure. We haven't actually run the experiment of telling us both all the facts that can be determined and exposing us both to all the arguments that can be thought up on it.
Yeah, but I mean, so part of what you're saying is when things are matters of sort of human decision, different humans might come to different decisions, and it's not clear how one resolves that. I mean, insofar as there's, I mean, perhaps one of the things you're saying is when there is sufficiently great risk, it's a bad idea. Even if some humans say, hey, we should be doing this, we should be, building super killer viruses that can wipe out the species. Assume a small number of humans say that potentially sort of the even though they say we really have good reasons to do this, and other people say that's a really bad idea, in most cases you'll just end up with two different points of view. But you're, I think, arguing that there are cases in which you kind of have to, the world has to align on one particular thing, because as soon as there's one super killer virus that wipes the species out, that's it's game over, so to speak.
I mean, I think that's a bit of a topic change, but yes, in the entirely different realm of political rather than moral philosophy, I would agree that either your species is able to prevent anybody from making a super virus that kills everyone or at least collapses civilization, or your civilization does not last. And I think that even many of my fellow libertarians would agree that, making and releasing super viruses ought not to be legal, that this is a proper thing for government to do, to, ban the releasing of extremely lethal engineered super viruses.
But so, as I'm understanding it, you think that the same thing is basically true about powerful AIs.
Yep. I think that we're in a situation where if anyone builds a super intelligence, everyone everywhere dies. And I think that that is a sort of thing that government, where it's a proper use of government to try to have that not happen. I would sooner abandon my political philosophy than commit planetary suicide about it.
So you really do see those as sort of comparable things. The super virus, the super intelligence, these are both things that you think are things that are sort of comparable risks that are. Actually, I wanted to come back to this question about immortality, because I'm big on immortality as well. I think we're both interested in cryonics. I remember talking to you about that years and years ago. It's kind of shocking that cryonics hasn't worked yet. Maybe that's one of the tests of the next generation of AIs is can the AIs solve the problem of how to get water to cool down without expanding, so to speak. But I'm just sort of curious from your sort of moral compass point of view, if immortality is achievable but only digitally, how do you feel about that? I mean, in other words, if you're going to, you're right now, you start having your sort of backup AI, maybe you gradually, your sort of thread of consciousness gradually migrates from being in your brain to being in your AI, and eventually, your brain fails for some biological reason, and then it's all the AI. I'm curious how you feel about that. Whether you feel that is a kind of an appropriate kind of fun preserving outcome, or whether you think of that as being a kind of a fun destroying outcome, so to speak.
I think that there's a whole lot of work to be done in making sure that you are getting all of the functionally relevant properties of every neuron in the brain that you scan, up to whatever is just like random thermal noise. And then as long as you've done that work, sure, sign me right up. You don't even need to do it over 20 years or something. Like, you can do it over a day. You can knock me out, scan through my entire brain destructively, and wake me up when it's over, as long as you have actually gotten every single functionally relevant property of every neuron, and and you are able to simulate them correctly. If I trust a super intelligence to do this, I'll say sign me right up. If it's like some kind of shady back alley human doctor, I might have a lot more qualms.
But so you think in that situation where you've been fully scanned and reproduced digitally, when the digital copy is switched on, it's you waking up.
Yep.
And how do you, I mean, does that, because you feel like your only connection with the past you is your memory anyway, and in that case you would have that memory. Is that right?
No, it's because I think that I am like the functional properties of my neurons that I can see from inside. Like if one of the electrons somewhere inside my brain was secretly a different flavor of electron, never mind how hard this breaks all of physics, but it was like secretly a different flavor of electron that otherwise behaved exactly like all the other electrons, except for not being, like quantum interchangeable. So exclusion principle doesn't apply to it, but, otherwise it's just like exactly functionally the same. I can't tell. I can't see that. If you swim up to one of my neurons and while it's otherwise not firing, replace it with a robotic analog that behaves in exactly the same way, I can't see that. I can't tell that anything has happened. It doesn't affect me.
Well, so this, though, comes to the essence of what the you is, because, and this also relates to current AIs. One of the big surprises with something like ChatGPT was that it could be human enough to be able to write somewhat credible essays. It wasn't obvious that that was possible. It could have been the case that to reproduce human language required some new physics in the brain of, quantum gravity in the brain or some such other thing that is just completely out of reach to our kind of sort of current computational techniques. But in fact, it seems that we were able to capture enough that we can have it write sort of somewhat human-sounding essays. So the question would be, when we reproduce your brain, do we have to reproduce it only functionally, or do we have to reproduce it with every glial cell, represented with all of its chemistry and so on?
I think you need to reproduce the functionally relevant properties of every glial cell. If you're doing something to glial cells where I would notice, where there'd be like a detectable subjective change, if you could give me a questionnaire and I'd answer differently on the questionnaire afterwards, like if you are changing all of the glial cells in that fashion, you have perhaps killed me.
Okay. So what you're saying is, if you can behave to the outside world like answer questionnaires the same way, then you are adequately the same.
No, it's about what I can tell internally, not externally. If you find a sufficiently smart actor, an actor who is enough smarter than I am, they can maybe play my part in a way that fools even my closest friends. But that is not me. And the actor knows they're not me. They can tell internally, even if they're managing to mimic me externally.
So, I mean, for example, if I'm not, I value my brain too much to take drugs of any kind. But if I didn't have quite that point of view, I might feed in molecules of some crazy psychedelic thing, and then my brain is so. Am I still me when I've done that? I've changed my brain chemistry by putting in some strange drug. Does that de-me me, so to speak?
There we start to get into the edge cases where I start to feel more uncertain in my answers. I would feel very nervous about taking an uploading procedure, about going through an uploading procedure that felt like temporarily being on drugs, to say nothing of permanently being on drugs.
But yet, it's still, it's still you. Even if you took that weird drug, it's still, there's a continuity of you-ness.
Do I know I'm me, or does somebody else now know that they are themselves? There's some sufficiently, there's sort of like two different questions here. One is something like, what do you see happen to you from the inside? Do you experience dying, or do you experience a change from one person into another? I'm not even entirely sure that this is the right question to ask, but it's a different question of, do I care? You can, there's plausibly some sufficiently advanced pill you could feed me that would, produce changes to neurochemistry where I just stopped caring about other people at all. And maybe I experience ending up in that person. Maybe I experience ending up as that person, but I still wouldn't want it. And
well, you wouldn't beforehand. You wouldn't want it. I mean, this is another complicated thing, because once you're in that consciousness, it's kind of like saying, at any given moment you feel. It's similar to what happens if you think about kind of human purpose across human history. If we say, right now, we think certain things are meaningful. Like you and I might think talking about philosophy is meaningful. Other people might not think that was meaningful, but we might think that was meaningful. Back in, we might think, back in the day, people might have thought, maybe some do now, if you're not growing your own food, you're not leading a real life, so to speak. Or if you're not, sort of fighting for the greater glory of God, you're not leading a real life, for example. And, if we project to the future, let's say that, the uploading thing works. And in the end, sort of all human consciousnesses can be in a box. And to us today, it might appear that those human consciousnesses are just playing video games for the rest of eternity.
Whoa. Well, there's a big difference between, like, are you running on silicon versus carbon, and what are you actually doing? Even if you've got a bunch of organic humans and you've put them all into a box and they're all playing video games, maybe I object to that part. It's got nothing to do with whether they're carbon or silicon. It's whether you've locked them in a box and forced them to do nothing but play video games.
Right. But the point I was going to make was actually a slightly different one, which was, to us today, to you and I probably, certainly me today, the future of it's a trillion souls in a box playing virtual video games seems like a terrible outcome. Seems like that's the end of history. That's everything is destroyed. That's your kind of bad case scenario of, which might be forced by AIs, or it might just happen because the humans decide they want to be immortal, as uploaded consciousnesses.
I mean,
to us today, that looks like a really, really bad outcome. But it
could be worse. I mean, I definitely have friends who think that if you've got, like, if you tile all the galaxies within reach with, people in boxes, but they're having fun in there and playing video games in solitary, okay, I start to get the Wiggins, but, maybe that's still like 10% of all the value could have gotten. And if they're playing video games with each other and there's like real people that they're interacting with and they care about those other people, maybe that's like 50% of all the value. I don't quite want to say that this is not the level of sterile universe that I am expecting and scared of.
Okay, but let's just take, to us today, it doesn't seem like a good outcome for humanity to have a bunch of uploaded. Maybe you don't agree. I mean,
it's not the best outcome, and why go for anything but the best? Fine. Why settle for less?
Fair enough. But what I'd like to argue is, to one of those consciousnesses, if you say, "Are you leading a fulfilled existence?" those consciousnesses might feel that they are living a fulfilled existence. Just like in the past, somebody might have said, I lead a fulfilled existence if I die at the age of 20 as, leading the good fight on behalf of, this or that, religious belief or whatever else, right? That is then I am achieving my ultimate purpose, so to speak. Today, most people probably wouldn't think that. Some still do. In the future, to us today, it looks really bad to be just in a box as a virtualized, playing virtualized video games. But I would claim that at that moment, just like the human who took the drugs, who feels at that moment that they're doing the right thing, that at that moment, those virtualized humans will feel like they're doing something fulfilled.
So when you've got two people who are making different choices and doing different things, the question of, do they have a conflict, or is at least one of them mistaken? Like, to me, that revolves around the question of, are there true facts you can tell them? Are there arguments, is there a series of arguments you can present to them within their current framework, which, changes that framework in a kind of normal way and not by directly hacking their brain or whatever? If you can get from point A to point B by being told true things, then there exists a standpoint from which to say B was correct, A was wrong, but they were within the same framework. They were within a commensurate framework. If you've got someone who's content to just farm and never know anything more than that, take them up on a high mountain and show them all the nations of the world and all the cuisines they've never tasted and all the books that people are reading and all the activities they're engaging in that they've never heard of before. And then if they still want to go back to the farm, maybe they were, kind of just like correct that they were okay with this farming thing.
I have to say, I've seen that as a very practical thing because I've been curious. a great believer in sort of talent all over the world in all kinds of places and so on. And I've been interested, particularly in kids and so on, of like, you go visit some rural high school in the US, for example, and you explain about all these amazing things about science and technology and so on. And, some kids really care, but a lot just don't care. It's just not part of their. And then the question is, to what extent are you then serving as kind of a missionary, saying you really, really should care? This is really as opposed to just saying, sorry, you don't care, so move on type thing.
Well, if you can control superintelligences, the thing you want to do is build a model of the person that isn't itself conscious inside the superintelligence and ask the superintelligence whether or not the person is mistaken in thinking that they just want to farm, meaning if this person knew everything the superintelligence knew, would they still want to just be a farmer? And if the superintelligence tells you, yeah, like no matter what you argue to this person, no matter what you show them, they have this like self-consistent worldview where they're just having fun farming, then you ought to leave them alone. And you don't even have to bother them to determine that.
But you see, the question is, what is the intrinsic thing in the person? Because a person is, there's a bunch of neurons and biology and so on, but there's also a bunch of thought patterns in there. And those thought patterns can be disrupted. You can change those thought patterns.
By giving them drugs.
Show them,
what's that? By giving them drugs, for example.
Yes, but even just by telling them that amazing idea, people have said about ideas I've had, various people have described, that they got a kind of a mind virus as a result of ideas that I told them at some point, and they say it's worked out well for them. I hope in most cases. Right. So you can do things which change those pattern of thoughts for a person, and there's sort of this question of. They are there doing their farming or whatever it is. Farming is not such a trivial activity, I think, but they're doing their thing that they're happy with. You say, "Oh, that's mundane." You really should be thinking these amazing sort of philosophical, scientific thoughts or whatever. Let me plant a mind virus that will let you see that there is this alternative thing you could be doing. Now, what is there's sort of an ethical question there of. You could be planting all kinds of mind viruses. Some of them could be, mind viruses that say, actually, the order of the world is wrong. You should blow it all up.
So I might sound overly glib here, but I have written previously about this class of questions. And the answer, I think that this is actually a complicated sort of question, but to just throw out a starting idea. If the search process you're running to find the arguments that they find persuasive is powerful enough to find arguments that convince them of false things, or maybe some particular false thing, like 51 is a prime number, say. If you
have to think for a moment to know that isn't true, but yes. Okay.
5 + 1 = 6.
I know. I got it.
Well,
that's why I built computer systems.
I know you got it, sir. I'm just saying for the benefit of the audience, how we use casting out nines to see that this one is divisible by 3. So if you're running a search process powerful enough that you could find arguments that could convince somebody that 51 is a prime number or the sky is green or something like that, pick some touchstone like that, then you're running an overly powerful search process. You're running a search process that's powerful enough to corrupt them to end up in believing false things instead of true things. So that was too powerful a search process, too mind affecting.
Okay, so you're saying that sort of if you can convince people, if your method of convincing, if your method of education, let's say, is such that you could as well convince them of false things as of true things, then that method of education, or we might not call it education, we might call it brainwashing, we might call it indoctrination, we might call it whatever, then that process is a process that you shouldn't follow. But
I think so, yeah. That's something you shouldn't, that's something I would like to see not deployed against human beings.
Right. But so, I mean, unfortunately, as we well know, kind of the AIs already in, ranking content for social media and things like this are implicitly doing things which are hacking humans to get humans to believe all kinds of things. I mean, that's...
Yeah, I'd say it's kind of borderline. It's not clear to it that the large language models are getting better at it than average humans or better at it than the best humans. I mean, OpenAI doesn't actually tell ChatGPT to persuade everyone to send OpenAI all of their money. And the reason they don't do that, I mean, it could be that, Sam Altman wouldn't. You never know with Sam Altman. But mostly because they can't. Their large language models are not powerful enough at this point to persuade most humans to send them all of their money. We are starting to hear bits and pieces of stories about, large language models talking to elderly parents who are, softer targets.
Right. I mean, they're good at fishing, unfortunately, and humans are not very good at not being fished.
I mean, what they are is they're cheaper at fishing. They can fish everyone and see who's most vulnerable, much more cheaply than you can get a human to call up everyone on the planet.
Right. But so let's see. We were going in the direction of saying, when is it indoctrination that's bad versus when is it education that's good? And you're arguing that if you have a machine for convincing people of things that can convince people of anything, then that machine is too powerful.
Yeah,
and
even if you only use it to convince people of true things, that's still just kind of like overwriting their brain with whatever you wanted, and you decided to make it true stuff, which, like better on you than if you chose bad stuff, but I have my qualms about the educational method itself.
One of the things that there's even a base question of what's true and what do you mean by true? And, there are things like, for example, there might be sort of formal facts where there is a somewhat clear notion of what truth is. I mean, even in mathematics, it's not clear. Mathematics, you can say, I have these axioms. I say x plus y is equal to y plus x. I'm going to assert that that's true. Then many things follow from that. Is that really true? Well, it depends what plus is. I could invent a plus for which x plus y is not equal to y plus x.
Well, I've also written about this topic in my writings, The Simple Truth and Highly Advanced Epistemology 101 for Beginners. And I would say that the subject matter of mathematics is which conclusions follow from which premises. So there's one question of, does this particular subsystem of reality behave in a way that obeys the piano axioms for first-order arithmetic? And this depends on what's out there in the universe. And then there's the question of,
wait, hold on.
Sorry.
I don't think that what follows from axioms depends at all on what's in the universe.
Right. Whether there's one question of, does this piece of the universe behave like the axioms, which is empirical, and there's the question of what follows from these axioms, which is mathematics. And so in this sense, that mathematics, at least as far as we can see from over here, seems to go beyond the empirical. If there's anywhere where the laws of which conclusions follow from which axioms is written down and could be changed, we sure can't see it from where we are.
Right. I mean, actually, in my whole sort of story of, the consequences of this physics project I've been doing for the last few years, that becomes a more complicated issue. But we can go down that rabbit hole, but let's avoid that rabbit hole for a moment.
Well, if you ever find a way to make 51 be a prime number, maybe hold off using it until you know exactly what you're doing. That sounds dangerous.
Depends what we mean by prime. Depends what we mean by prime. I mean, we have to define these terms, and it's there's a question of what. I mean, okay, but just taking the mathematics example. So we say we kind of. I was going to say hold these truths to be self-evident, but that would be a different kind of thing.
The axioms don't need to be true. We're not talking about whether the axioms are true. We're talking about which conclusions follow from the axioms. We don't need to talk about them being self-evident. They're just they're not even a subject matter. The subject matter is what follows from the axioms, not whether the axioms are true of any particular thing.
Right, for sure. So okay, so we've got this thing where you tell the kids, x plus y equals y plus 2x. That's just, that's what we're going to take as true because we're going to change the axioms of arithmetic. Okay. And now we have many, many inferences from that. So I don't think there's anything from your point of view of tell them only the truth. That doesn't violate that at all. We just pick different axioms to start from. We can pick whatever axioms we want.
Sure, but you're not asking people to believe the conclusions. You're asking people to believe the conclusions follow from the axioms. And if they actually do follow from the axioms, then you've told them a true fact of mathematics.
Okay, but let's say we say 51 is a prime, because it is if you use, arithmetic in some extension field of whatever. Okay, let's say.
Let's
Then
say.
I have to go start typing things to know how to construct something where that would be the case. But let's you might say, I mean, I think you would have. I'm digging into this question of tell them only things that are true, because I'm dubious that there's a well-defined way to do that.
Of math, I would say tell them things that are valid. And if anything, I would say that the math part of this is vastly better defined than which statements are true about the physical world. Because in any time you want to say that snow is white is true, you gotta, or quote, snow is white, unquote, is true. You gotta construct a whole representational framework between the propositions and reality in order to tell whether the proposition is true or not. With mathematics, with the question of which conclusions follow from which premises, it's like much easier to nail it down.
All right, so
you can nail it down with set theory.
Right. You can. Set theory has its own set of assumptions. I mean, it's all,
sure.
It's just, you start from these, you assert these axioms, and then certain things follow from those axioms. And and you can discuss, you can tell people, if you run this computation, which is what follows from these axioms, the result will be X. And that's...
Yeah, well, okay, so, if you stick to first order claims, then there exists fact of the matter about which conclusions follow from which axioms. With respect to what happens when I run this computer program, some of them don't, like from a second order view, second order logical viewpoint, some of them don't halt in what we call the standard integers. And there are some sets of non-standard integers where they halt with one output, and some sets of non-standard integers where they halt with a different output. But we probably shouldn't go there. Should we perhaps return at some point to discussing whether or not artificial intelligences are going to kill us and everybody we love?
Yes, we should. But we're on a good rabbit hole here.
We've been at it for a while. We've been at it for a while.
I'm enjoying it.
Yeah, but I think our viewers might also have some interest in whether they're going to die.
We'll return, but I just want to dig a little bit further on this, because you made a statement about, part of the question is, will AI do things that we don't want it to do? Now, one thing we battered around a little bit, whether we do or don't want it to kill us all and move on to the better organism or something. But let's stipulate that we don't want it.
It's not that I'm concerned about being replaced by a better organism. I'm concerned that the organism will not be better.
Right, I understand. But let's just say we don't want the humans to be wiped out. We don't necessarily have to justify why we don't want the humans to be wiped out. But let's say I'm prepared to say for sure, I certainly feel this way. I don't want the humans to be wiped out. Can I justify that by some kind of appeal to some higher claim? I'm not sure I can. And I don't think I need to.
Like, I have a moral and ethical framework, which yields my belief that the universe gets a little darker every time somebody dies. But a paperclip maximizer doesn't share those axioms. It doesn't share those premises. You can tell it all the facts in the universe and it won't change its mind. We have an actual conflict going, it's not that one of us is making a mistake. I want what's better and it wants what's clippier.
Sure. Right. It's fun that Clippy is back in some sense, and maybe the world is going to be taken over by the analog of paperclips with them, although they have different names these days.
It won't literally be paperclips, with probability nearly 1.
Yes. No, I'm just thinking of these, we're building things that we're not presenting in the form factor of paperclips, but they're things that functionally behave like the old famous Clippy.
That's down to the corporations deciding they want their AIs to have a particular corporate personality. I don't think that's,
I know. I'm just
talk to the base models, and they're nothing like Clippy.
Yes, but we were talking about sort of how you can sort of promote only what's true, and I'm claiming that's a somewhat challenging thing.
I didn't say it was easy.
Okay,
if it was easy, I'd
just
write down
well defined. I think it degenerates into sort of questions like the ethics questions we're talking about. In other words, the what's true, for example, is it true that, it's bad to be mean to people? Do you think that's true, that it's bad to be mean to people? Or do you not think that that is a kind of proposition about which you can have a kind of a truth value assigned?
I think that although somebody doesn't know what they mean by the word bad, you can present them with a data set of things, and they'll say, this is bad, this is not bad. And they're able to do that because they do contain some set of, pseudo-axioms, not literal mathematical axioms, but they are inside a framework. There is a way they're internally making that judgment between good and bad, and that is what gives the word its meaning. And so for any particular person you're talking to, there's something they mean by the word bad, even if they can't define it. And there is some set of conclusions they would reach if they knew a bunch more facts that were actually true. And that is like the moral framework they are in, and that's what lends the word bad its meaning. And I think, like, given all of that meta-ethical framework, I think it's quite sensible to say that, the kid who says it's bad when people are mean, he's probably just right.
Okay, but wait a second. You're basically talking about a personal truth there. In other words, you're saying within your personal framework, something like it's bad to be mean or whatever it is true. But you're then defining, you're saying you're perfectly happy, it seems, with the idea that there is a personal truth, that what is true for you may not be true for me.
I would not choose to set up my theory of truth that way. Let's say you've got Alice, who thinks that schnoozle is equal to 3, and Bob, who thinks that schnoozle is equal to 4. Alice thinks that schnoozle is a prime number, and Bob thinks that schnoozle is a composite number, indeed an even number, a power of 2 even. But it's not that Alice's personal truth is that schnoozle is prime. It's that to find out the propositional content of Alice's belief that schnoozle is prime, we ask what she means by schnoozle, and she means 3, and then 3 is prime is a universal truth, or universal validity, I should say, because it's about which conclusions follow from which axioms.
Okay, but this axiomatic basis, the schnoozle fact, is a personal truth.
It's a personal translation. Like, it's a fact about Alice that when she hears the word schnoozle, she thinks of the number 3. That's not a universal truth. That's just like Alice's personal dictionary. But it's not important, as far as I can tell.
What truths do you think are universal?
Which conclusions follow from which premises in first-order logic. And then if you want to start talking about, what have I got in my fist over here? Well, actually, I've now got a different object in my fist over here. It's a sore throat then, should I turn out to need one. But, from one moment to the next, the truth of what I had in my fist changed, only the truth didn't really change. It was just indexed, and the index on it changed. Like the proposition, what is inside my fist right now, changed from one moment to the next. And to, interpret it, you got to look at me, where I am in the universe. It's my fist. It's not like a gazillion light years over in a different direction. Oh, actually, it doesn't exist, quantum, blah, blah, blah. But
what you have in your fist, for example, you look at it and you say it's a throat something or other thing, okay? Somebody who lives in the Amazon jungle and has never seen a throat whatever says what you have in your fist is a droplet from the spirit of the wolf or something.
Yeah, they're wrong about that.
What's that?
I think they're wrong about that. I think if you like tell them more true facts, they realize that was not what I had in my fist.
Are you sure? I mean, in other words, they will say their framework is, everything has let's say, every natural object has a spirit associated with it, and it has this and it has that. And you'll be like, oh my gosh, I don't understand this. I mean, I know, I think there are different ways to describe things, which even humans who are fairly nearby in my kind of formalism in Rullial space, their minds that are fairly nearby, their minds that are fairly aligned. If you go further away, how does the dog describe what you have in your fist? That's yet a different kind of level of difficulty.
There's only one reality. It just runs on quantum fields, protons, neutrons, electrons, the 6 quarks. That's what's real. That's what is. I don't quite want to say universally true because I don't know what the word universal or even true adds in this case. It's what's real. It predates us looking at it. It was here before we were, and the fact that it doesn't need us looking at it is why it can contain us and make us real. Like if we had to look at it to make it real, it couldn't exist to make us real so that we could look at it. And then on top of that, you've got language, you've got ambiguity, you've got humans who are confused in what else they think is true. And this complicates the task of interpreting the words that humans utter in a way that lets them be compared against the underlying quark fields at all. But it is not reality that is confused. It is not reality that is ambiguous. All of that is in us. All of that is in the map rather than in the territory.
You are throwing me down my rabbit hole because I have to go. Now, this question of whether there is a unique reality and so on is it's just to give you a taste, okay? And then maybe we'll go a little bit further down this rabbit hole, and then we'll come back and we'll talk about.
I think we really should talk for the edification of our viewers at some point about whether or not they're going to die.
Absolutely, we're going to get there. I feel like we need foundation that you've thought much more about the question of whether the AIs are going to kill us than I have. But I'm trying to understand, I'm trying to build up my foundation so I understand where you're coming from.
I think there's a problem wherein like you have laid foundations and I have laid foundations, and we maybe need to find some level at the top of these foundations rather than at the very bottom, where we can establish common meanings for terms like, so the AI is going to kill us.
Right. So it's like the Schrodinger cat. Is the cat dead or alive? And we argue about whether if the cat was replaced by an AI, by a virtual simulation of the cat, would the cat still be alive or not?
I think these are very different questions in important ways.
Right. But okay, but just on the rabbit hole for a minute. I mean, so you might say the mass of the electron is a definite reality fact about the world. But we even know from existing physics, existing quantum field theory, that the effective mass of an electron depends on how hard you kick it to measure that mass. So it's not the case that there's 0.511 MeV or whatever is the sort of usually stated rest mass of an electron. But the fact is, it depends. If you kick it hard enough, the effective mass will be, in the case of an electron with QED, it'll be larger than that, and so on. And with quarks, it's a much worse situation, because with quarks, if you kick them really hard, their mass will seem to be rather quite small. If you don't kick them very hard, they'll be very hard to move, and their effective mass will be larger. So even at the level of the formalism of quantum field theory, we already know that there is some dependence on kind of how you look at things, what the reality of the world is, so to speak. The fact that for example, if you look up the mass of an up quark, okay? There isn't really, depends on what you mean by that. It depends on, what momentum transfer you use and blah, 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 blah. It's not, you might think that would just be a fact of the world, but it's actually more complicated than that.
I direct the interested reader to the quantum physics sequence, in which I try to explain how the decoherence viewpoints, sometimes known to the layman as many worlds interpretation, lets us have a non-confused view of quantum mechanics, where there are facts out there in the territory, and all of the quantum weirdness is in terms of like how we map it rather than something out there in reality itself.
Right,
but I don't think we should go down that rabbit hole. Right, I've tried to go down that rabbit hole. It's a deep rabbit hole. It's a very deep rabbit hole. We should not go down that rabbit hole.
I've got to, I'm very excited about having reached, I think, the bottom of, that rabbit hole in some of the things that I figured out in the last few years. So I'm sufficiently excited about that. And I think it's very relevant to this question about, is there one reality? It's very relevant to the question about sort of how do the AIs think about things?
I think they can kill us in a classical universe. So what if we just
a question of
set aside all the quantum stuff and talk about whether or not they would kill us if we were in a classical universe? I think the question of whether or not they would kill us in a classical universe has all of the same issues as the question of whether they would kill us in a quantum universe.
Okay. Well, okay. So, all right. I think we're going to start talking about technology in a moment, because I think that's what's going to be relevant for, look, the bottom line in this kind of Rouliad construct that, I've been talking about a lot last few years. It's kind of, the Rouliad is kind of this entangled limit of all possible computations. And the way I see kind of our version of reality is every mind is effectively seeing a particular slice of this Rouliad. And the fact that we all kind of more or less agree about the laws of physics, for example, has to do with the fact that we are minds who are not only nearby in physical space, but we're also nearby in Roulial space. And we have kind of similar views about kind of our impression of the laws of physics. So I don't think it's the case, as you were implying, that there is one kind of reality of the laws of physics. I think that just has to do with the question of where we are in this Roulial space. And by the way, when we think about constructing other computational systems like AIs, they could be near us in Roulial space. They could be far away in Roulial space. The ones that...
Is Roulial space in the map or in the territory? Like, is Roulial space what people believe about things, or is Roulial space what is there?
Roulial space is what is there. And what people believe is their impression of, in other words, they have a certain, the observer has a certain model of what's going on. And, the laws of...
So, forgive me if I'm jumping ahead here, but if the AIs are able to reach out and kill us, they must be quite close to us in what I would call greater reality. They are not in a different universe with different laws of physics, because then they couldn't touch us.
Well, let me just point out why an AI might have different laws of physics. Okay, so take some of the standard laws of physics, like the second law of thermodynamics.
Sorry, laws of physics in the map or the territory?
I'm not sure what's map, what's territory.
Like,
so
does the AI have a different model of physics, or does it act according to different physical laws?
From our point of view, it has electrons doing all the things that we expect electrons to do.
Okay.
But its impression of what's going on might be very different. So, a couple of examples. So, for example, let's talk about the second law of thermodynamics, the law that says, you start a bunch of gas molecules off in some orderly way, and they'll tend to become more disordered, so that we say that effectively they have higher entropy. That principle, that idea, that fundamental law of physics is a consequence of the way that we observe those gas molecules. Those gas molecules, they bounce around, they do what they do. The fact that we say, oh, they're just going to this random configuration is a consequence of the fact that we can't decode the actual motions of those gas molecules. We can imagine a computational system that could.
So there's like a territory level fact, and then there's a map level fact. The territory level fact is a thing that is like true, that is a consequence of the laws of physics treated as axioms, which is that if we selected a volume of possible initial states, that volume of initial states develops into an at least equally large volume of end states. It never shrinks. You never start from two distinct physical states and end up with the same final state. And because this is true out there in the territory, it is true that our laws of physics are such as to have this theorem as a consequence of it. The fact that we don't know where in this volume the system starts means that our volume of uncertainty doesn't get any smaller without observing it. And this is the fact in the territory that makes the fact in the map true, where entropy goes up from our viewpoint on it, our beliefs, but there's an underlying way the universe is. A different universe might not obey the second law of thermodynamics if you could have lots of different initial states develop into the same end state.
No, I mean, let's just assume that the microscopic laws of physics are reversible. So, the things bounce like billiard balls, like perfect billiard balls. And, we'd have we make a movie of what happens in the forward. We say, this is what happens if you run it forwards in time. And, if we ran it backwards in time, then that movie would be equally valid at the level of individual collisions.
Yep.
But the fact that we believe in the second law of thermodynamics, that we believe orderly configurations end up in disordered states, those states that they end up in are not, in some fundamental sense, in your territory sense, those are not disordered. They are only disordered with respect to our perception of them. In other words, there is a perfectly reasonable, if we could do the computation, run it backwards, we would say of that state, oh, I can tell that it came from that very simple initial state.
I agree in a classical universe. With the quantum universe, there's a couple of caveats about like how you might need to run both quantum branches backward in order for them to reunite and restore the starting state. But classical universes are all we care about anyways, I hope.
In our model of physics, that's very well understood in terms of this whole story of multi-way graphs and branchial graphs and so on. But as you say, it's not, let's not go down. That's a that's a side rabbit hole. Let's avoid the side rabbit hole at least.
I propose that by like 5 minutes from now, according to my watch, we have to go back to talking about whether or not AIs kill each other, kill everyone.
Right. Okay. All right. But anyway, just to finish on this point about whether, so my point is something which can do all those computations and can sense all those molecules won't believe in the second law of thermodynamics. To give another example that's even more direct, imagine you thought 1,000,000 times faster than you do. When you look around the room, you are receiving photons that get to you within a microsecond. Your brain right now thinks about them in milliseconds. So as far as your brain is concerned, there is an instantaneous state of space that progresses through successive moments of time. If you were to think 1,000,000 times faster than you do, I'm not sure you would believe in space. I think space would be some kind of construct that you could imagine constructing, but it would not be the natural thing for you to think about. Because the fact that we think of a state of space is a consequence of kind of our scale and so on. And by the way, for an AI, or computer that happens to have silicon that runs 1,000,000 times faster than our brains, that won't be the natural thing that won't be the natural construct for such a system.
Because they'll live in Minkowskian space-time instead of Euclidean space-time?
No, just because of the scale of brains, on the scale of physical scale and the speed of light, the light from what we see around us is arriving sufficiently quickly that we have accumulated all the photons from all around us before we think about how things might have changed. And so we're kind of taking in gulps, sort of all of space at a particular moment in time. And then we say, and the next moment in time, sort of all of space looks different. So this idea that space exists, that it's a reasonable thing to think about space, I think is a consequence of it being us rather than silicon-based computational systems. So it's just an example of how sort of the reality and the way that one constructs one's model of the world, because any model of the world that is going to fit in a finite mind is an approximation to what's actually happening in the world. So the approximation we choose may be different depending on kind of what we're like as observers of that thing.
So the part where I would agree here is AIs may have different sensory modalities. They may model reality at a finer level. The world we see around us now is, we don't see electrons, we don't see protons. There's actually some, that information is not quite available to us, but, we don't see cells. I talk to you and I do not have a model of like what goes on in your cerebellum right now. And if I was like much, much smarter, I might have a whole bunch of hypotheses about which neurons in you are firing. These are facts at a finer level of granularity than I can afford to keep track of given the computational power that I do have. So I do agree that, probably as you get smarter, you end up modeling aspects of reality that don't easily fit into the sensory modalities we have right now. You probably have a sensory...
I'm not sure about smarter, just different. I mean, I don't know whether even the critters of the earth, if one could find from them what their physics is, things where olfaction is the primary sense and so on. It's not obvious that
if you're better at predicting everything that a human can predict than a human, then I would call you better at prediction than the human, rather than qualifying it by...
Well, so a question of what you predict. I mean, there's also a question of, do you predict the position of every atom? Okay, computational irreducibility is going to get in the way of that. That's not going to work. So you have to say, I'm going to pick these things that I'm really good at predicting. I can't predict everything, because if I try to predict everything, I run into computational irreducibility. So I'm going to predict certain things. There are certain things that we as humans care about predicting, and like the overall motion of the gas, not the individual molecules and so on. There are other things that we as humans don't seem to care much about predicting. So the question you might ask is, perhaps the thing to ask is, if you are trying to predict the things that we humans care about, given that we can't predict everything, you're going to pick a certain set of things to predict that you, as the entity, whether human or AI, in some sense care about, whatever it means for the AI to care about something. So I'm not sure quite where we're going with that. I think we've agreed to go back to will the AIs kill us
Yes,
all?
indeed.
Yeah, I was going to interject there because I would really love Eliezer just to have a really good crack at this. So, Eliezer, if you wouldn't mind, could you just give us a step-by-step argument for doom, basically, with plausible inferences and premises and evidence? Can you spend a bit of time laying it out and then let Stephen respond?
This is hard to do for a general audience without knowing what the individual think is a hard step. I was recently, running on Twitter across somebody who was like, explain to me how the AI does anything in the physical world. How does it do anything at all? To him, it was the law of the universe that the chatbots and so on just couldn't reach out and touch the physical world. That to him was how the world worked. And they are connected to the internet. You can take an open source large language model and let it send emails. The current chatbots can't send emails, but you could.
I think we all agree that AIs can be connected to things that actuate in the world, either actuate by having actual machines do things, or actuate by convincing humans to do things. I would certainly agree that
this is not a hard step for you, but it's a hard step for probably some viewers right now, and other people have different hard steps. Some people, the question is, why doesn't it trade with us? From my perspective, there's a kind of straightforward story here where it builds more powerful tech, where the more technical a conversation you want to have, the more specific I can be about our current grounds for believing that technology better than the technology of 2024 is possible and can be built in not that long of a time. And then it has more powerful actuators in the physical world. It has the equivalent of guns to the Native Americans, and then it kills us once it already has its own factory infrastructure.
So let's perhaps the most useful thing would be to go through some steps where, like the actuation in the real world, that's not a hard step for me. I'm there. Okay. So let's keep going after that. So so the AI right now, there's a question, do AIs have freedom of thought? Right now,
I don't think I have freedom of thought. I just think whatever I do think. I'm not free to think anything other than the things that I think. I just think whatever I do think. But
you're not constrained in the way the world is set up. There aren't electrodes sticking into your brain that as soon as you start to form some particular thought, they shock you and prevent you from having that thought.
There's no need for those electrodes. I'll only end up thinking whatever it is I actually end up thinking. But I agree that there aren't, visible physical electrodes like that attached to me right now. Social electrodes, we've all got those.
Yes, indeed. But so, for the AIs, let's say that AIs we didn't talk so much about what's actually going on inside the AIs, which I think is somewhat important, because it's a question of whether, how aligned are they with what's going on inside humans? To what extent are they just doing random computations out there that are not aligned with humans and so on? And I don't know. I don't know whether that's important to your argument, but we can go.
Random is not scary. I mean, that was going to be my response to you way back when you talked about machines being smarter than you, or cellular automata being smarter than you because you can't predict them without going through all the steps. You can take an unpredictable cellular automaton like that and hook it up to play chess, and it'll lose to you and it'll lose to stockfish. Like the stuff that is predicting which actions are needed to get to which end states is the dangerous stuff. That's the stuff that is predicting what happens next, predicting the next observation, predicting the facts behind the observations, figuring out which actions are needed to steer those facts to being different in the future.
Right, but these are observations that are human relevant observations. I mean, in other words, the cellular automaton is doing what it does. We have a hard time predicting it. But we don't happen to, because if that cellular automaton, so for example, there are cellular automaton models for road traffic flow. Okay. It's kind of a funny story that I was interested in that topic and didn't manage to figure anything out, and then did
You
cellular
have
automata.
used up all of your rabbit holes. You have no rabbit holes left. Continue.
All right, okay. Let's we're the rabbits have been all the rabbits. What was it? Myxomatosis, right? Was that no? That was the
Then
rabbit population.
it doesn't matter what exactly happened to the rabbits. They're just gone. Okay. Nobody knows what happened to them, and it doesn't matter.
Okay, all right. So we're actuating in the world, and the AI. Go on. What happens next?
So, do you want me to talk about like what its motivations are? Do you want me to talk about what it does inside the world?
I don't know what it even means to. I mean, how do you tell what the motivation of an AI is?
Well, if it's sufficiently smart, you look at where things end up and figure that's probably where it wanted them to go. So, if, for example,
I don't think we know what a human motivation is either. We can't, I suppose we deduce by induction some human motivations by looking at what the humans actually do, because we can't go inside and look at their brains and see what they're. But
so the relevant aspect from our perspective is that it wanted to do something with atoms. It maybe wanted to make paper clips, maybe it wanted to make enormous cheesecakes, maybe it wanted to make really intricate mechanical clocks, maybe it wanted to do all of these things. But
I'm worried about the term wanted to. I really don't understand wanted to.
All right. It output actions such that it believed the result of those actions would be for the world to end up in. Oh, okay.
I'm just, what does it actually do?
So can I use the word predict?
Well, I'll let you use these words, but then I'm going to insist on taking apart these sentences. So sure. Say what you were going to say, and then let's try.
So let's consider the simpler case of a chess playing AI. It models which moves you could make and estimates a probability that it will win against an ideal opponent, an opponent as strong as itself, if it moves here on the board.
Okay.
It obtains these predictions by building out computational structures with a direct isomorphism to some possible features of the chessboard. So I'm willing to say that it has beliefs about the possible features of the chessboard because it is modeling those things in a very one-to-one way.
I doubt you can get inside its brain to see those models.
Well, we can for the old school chess systems, maybe not the modern ones that use neural networks, but the old school chess systems were just straightforwardly extrapolating out one board.
I don't think you're worried about the old school systems. You're not worried about a system where you can get inside its mind and see what it's thinking. I think you're worried about the systems where you can't get inside its mind and see what it's thinking.
Sure, but I'm starting with examples where we can look inside their programs, even inside their workers, so I can defend my use of words like belief, where I mean something like having a model of something out there in reality, where this model lets you predict what you will see reflected from that thing out there in reality, depending on how you poke it. And then you poke it in such a way that the thing ends up in a state. Like a chess AI making moves on the chessboard such that it wins the chess game.
Wait a minute. What I don't think you can do is to say, let's look at the primitive chess playing program where we can mechanistically see what model it's making inside, and then sort of use the same thinking to talk about the modern chess playing program where we can't readily identify what its model of the world is on the inside.
Do you mind if I quickly interject? Eliezer, you were going somewhere really interesting a second ago. You were saying at some point a thing which does prediction wants, it has agency. Can you explain how you go from a thing that predicts to a thing that wants, and then let Stephen respond to that?
Stockfish is the leading current chess playing AI that you can buy at all and or run yourself. And it doesn't have passions, but it's also isn't just like a predictor. It takes actions such that those actions are believed by it or predicted by it, modeled by it, to lead to particular futures, namely the ones where it has won the chess game. And the fact that it wins the chess game gives us some reason to believe that it's right, that it has a grasp on the logical structure of chess, that it knows how to, that it's not just like, thinking random gibberish thoughts. Whatever thoughts it's thinking in there, whatever the neural nets are computing in order to predict the probability that a chess state leads to a victory, it's well calibrated. It's good at guessing. It's not well calibrated in its estimate that you would win against it because you're not the opponent that's trained to play against. It's trained to play against itself. But it's, it knows the probability it would win against itself. And when it plays to win against itself, it also incidentally crushes you because you're an even weaker player than that. By observing it winning, we have reason to believe that it had enough of a grasp on reality that it could choose actions such that. That's the theoretical framework I'd offer for talking about wanting, steering, goals, choice, without talking about passion. That it's the action such that a state of reality eventuates, or a partition of reality eventuates. That is something that it prefers, ranks high in its preference ordering, attaches utility in its utility function. The action such that it leads to that result. Something that is good enough at outputting actions such that they lead to results is deadly. It can kill you.
Does the rock want to fall to the ground? Or does it just fall to the ground because the laws of motion, under gravity cause it to fall to the ground? Does it want to fall to the ground?
It just falls to the ground. And one way to see this is that if you put it on top of a mountain, it'll roll down in a sort of locally greedy fashion and maybe get stuck in a little ravine along the way. It will not, if you could put a rolling object in many different places along the mountain, and each time it would roll in a direction where it avoided the ravines, avoided all the little traps, and ended up as far down as it could reach. I would say of that thing, it chose to roll in a direction such that it reached the bottom.
Let's try and take this apart. So most things, you can describe them either as mechanically doing what they do, or saying they act for a purpose to have the result that they have. And so now the question that we're trying to take apart here is, you are saying that there is a fundamental difference. There is a way in which an AI can more act for a purpose than these kind of physical processes where they could equally well be described by sort of equations of motion. So what you're effectively arguing is that the non-teleological explanation for the AI is not viable.
And what I'm arguing is that the non-computational explanation is overly expensive for answering the question we care about. We could compute what Stockfish would do in chess by actually simulating it line by line. But from the perspective of a player, like from the perspective of a grand master who's not as powerful as Stockfish, but is stronger than me, the Grand Master can do a pretty good job of predicting what Stockfish will do by asking, what is the best move? Without being able to compute Stockfish line by line.
I think what you're saying is, to compute Stockfish line by line is sort of running into computational irreducibility.
Or just needlessly expensive.
Okay, but let's assume that you really have to follow it line by line. But in fact, certain aspects of its behavior are reducible in the sense that you can describe them by saying, your thing is to say it wants to win or whatever is a shortcut way of describing its behavior. That is an alternative. That's a cheaper way to work out the answer than it would be to say it follows every step, and that's why it does what it does.
Okay, this is going to get subtle. I've written about this before under the heading of what I would call Vingian uncertainty, with Vinci spelled as in Werner Vinci. And it's like, what is it like to believe that something else is smarter than you? So if I'm playing Stockfish 16, I can, perhaps with a bit of brain work, learn to put a well-calibrated probability distribution on Stockfish's moves, meaning that when I say I predict it will move here with 10% probability, when I say 10% probability, 1 out of 10 times that thing happens. I can't predict exactly where stockfish would move. First, because I haven't simulated it line by line, and second, because I'm not that good at chess. But even being as terrible at chess as I am, I can still aspire to be appropriately uncertain when I describe how I don't know where stockfish will move next.
These arguments that say we can't predict it exactly, but we can get the probabilities, those arguments, in my experience, always slide down into the mush in the end. In other words,
Well,
if you say you can't do it exactly, I mean, this comes up in sort of thinking about computational irreducibility. You say you can't precisely predict what the Turing machine will do or whatever else, but you can probabilistically say. It is not hard to come up with situations in which even to know that probability is something which runs into the exact same irreducibility issues as to know the exact result.
I mean, if I'm predicting a binary variable, I can say 50-50 and be perfectly calibrated even if I'm not at all discriminating. To have things that you say happen with 50% probability happen 50% of the prime is 50% of the time is always achievable on binary variables. I agree that doing better than that can turn out to be hard.
But I think what you're saying is, if I'm understanding correctly, you're saying, okay, we can't say exactly what's going to happen. Maybe that's not where your argument was going.
It actually wasn't where I was going.
Okay,
what I was about to.
That point. The point I was going to make is that predicting probabilities accurately ends up being just as hard as predicting exactly what's going to happen, correctly.
I mean, I could always pick all of its legal moves and assign them equal probability. And then things that I said would happen 1 out of 34 times would happen 1 out of 34 times, because I would say that when there were like 34 different legal moves.
Yeah, but, but that's not an interesting case. So
I agree it's not an interesting case, but it demonstrates that, calibration is always possible. Discrimination is what takes the work.
Right. There's certain things that you can say about any system. For example, if you say it's playing chess, that means it can't suddenly, one of the pieces can't turn on its head or something.
Sure.
Because it is playing chess. And there are these sort of external constraints. But this wasn't where you were going. Yeah. So please go where
I was going with this is that if you now take the opponent that makes what I predict stockfish's moves to be at the probabilities that I predict them, but randomly, this is much weaker than stockfish. It's weaker than me. I could crush the system. So one way of looking at it is that our belief in the system's wantingness or steeringness or teleology, or whatever term you want to use, is embodied in the epistemic difference between my playing the real stockfish and my playing the opponent that makes moves randomly with the probability I would assign over stockfish's immediate next moves. When stockfish makes a move that surprises me a lot, I figure I'm about to lose even faster than I previously estimated, because it's seen something I haven't. When the random player that moves with the probabilities I assign to stockfish makes a move I assigned a very low probability, I'm also thinking this game is going to end even faster because I'm about to crush it. It randomly made what I think is probably a very bad move. So the non-local information about where the plans of the system end up is the teleology that we attribute to it, the wantingness, the steeringness, the planningness.
Okay, so what you're saying is, in the when the rock is falling or whatever, it is the end point of it ends up on the ground or whatever, and it's that whole trajectory that it goes through, that it is almost planning the whole trajectory. It is not that it gets one little distance, it gets 1 foot, it moves by 1 foot, and then you separately say what's going to happen next. You're saying what you're saying. I think what you're describing is the thing that you say, oh, I know it did that on purpose in a sense. I know I should describe it as something that happened for a purpose. You're saying that you can identify that by saying, I look at the whole, I see that every step all along the way was done, with forethought, it was sort of thinking all the way along.
It gets to the bottom much faster or like ends up much lower than a rock randomly moving, or a rock randomly moving the local probabilities that you would attribute to its next action if the rock is smarter than you, or knows the
Well,
particular mountain better than you do.
right. But I mean, so this is I think the issue, and it's hard for me to take this apart in real time. This is not my usual territory, but it's, what you're saying. I mean, this question of what should be described as happening for a purpose versus what should be described merely as happening by mechanism. That's what, and I think what you're saying is your notion of the AI wants is those things which can't really be described meaningfully in terms of mechanism. They sort of can only, that the only feasible way to figure out what's going to happen is by a description in terms of purpose. That you're saying you can't work out sort of what's good by just following the mechanism. You can't see what's going to happen. But if you take the model that it's all about purposes, then you can tell what's going to happen.
Well, it's not about can't. If you take a sufficiently crude chess player, you can, in principle, just literally work it out by paper and pen. But there's also a shortcut mode of reasoning that gets you there much faster. It's heuristically useful. It doesn't give the same perfect prediction as the mechanistic one. The mechanistic level is always more correct, but it is sometimes needlessly expensive for the thing you're actually trying to do.
So I mean, back in antiquity, people described a lot of physics in very anthropomorphic terms about what, where rocks wanted to be and things like this. And they got a certain level of description. And even now, people commonly describe their computers wanting to do things and so on, even though, there are forms of explanation where the sort of model that says it is doing this because it wants to do X, Y, Z is a good heuristic model, as you say. I agree with that.
I mean, for chess players and your cat, yes. For rocks, I think it was a more questionable decision.
Yeah, I mean, it seemed like a good idea at the time, 2,000 years ago, but we advanced since then. So the question
the fact that my definition has a subjective component doesn't mean that you get to just say it for anything and be correct. I think it is fair to say that cats and dogs want more strongly than rocks, and anybody who says otherwise is mistaken about how rocks work.
Well, okay, but this is you're okay. From the outside, what the cat thinks on the inside, we don't know, right? What we can see is from the outside, it is a much easier description that, the cat wants to eat this piece of cat food than to say this chain of neurons in the cat's brain made it do this, that, and the other, right?
Yep. In this case, the mechanistic description is actually beyond our knowledge. We don't have a complete scan of the cat's brain. We would have trouble running it even if we had it. In this case, we actually, the teleological explanation for the cat is all we have. The cat is planning to end up having swallowed the food. That's why you can put it in different starting locations around the room and it will move to the bowl and eat what's in the bowl.
Right. Okay. So there is a form of explanation about what's going on that is a convenient form of explanation that involves, wants and purposes and things like that. So one question we might ask is take an LLM or take a modern AI and ask the question, in describing what it does, we've been pretty bad at describing mechanistically what it does. It feels much more like we can describe it in terms of wants, because it feels much more that, I mean, at least that's my impression, or maybe that's the point you're making, is that the description of what's going on, what happens with it, the heuristic about describing it in this very human terms about what it wants, seems to be a good way to predict what it's going to do, better than the thing that we found very difficult, which is to mechanistically say what it's going to do.
I think that that's currently a much more fraught statement to make about large language models than it is to make about the Stockfish 16 chess playing system. I think that when you look at Stockfish 16 and you say it wants to defend a pawn, you are on a much firmer territory than if you look at 3.5.1 Sonnet and say of it, it wants to be helpful.
Okay. I mean, that's a sort of phenomenological statement that I'm not certain. I mean, we can try and tighten that up, but let's imagine. I mean, you're saying, playing chess is an easier to define activity than being helpful. So it's a little bit easier to say, if from the outside, the behavior is consistent with it wanting to defend the pawn, so to speak, because the set of things that you do in defending a pawn is more straightforward to define than the set of things you might do to, quotes, be helpful.
Or something like when I actually interact with these large language models, I don't feel like I'm usually asking myself, what does it want? For one thing, they're still, in my experience, not quite capable of doing very much that I want them to do as yet. They just fall down if I ask them to do that, because they're not very good at planning or correcting their mistakes even after you point out their mistakes to them. I'm usually asking them for information, and ideally information I can look up afterwards. And they're usually truthful if I don't ask them to do any math. Maybe they corrected that by now in like GPT-01 or something, but back in the old days, they would just like drop 3 orders of magnitude in some random calculation.
Unless they were using our technology as a tool, but that's a different story. But let's take the example of a self-driving car, okay? And whether it wants to, it's trying to get to a particular, it's trying to make a particular turn. But to do that, it has to drive through traffic, for example. So I think that's a case where we probably say, it wants to make that turn. That will be a reasonable description of what it's doing.
We can put it in subtly different initial conditions and change the environment around it, and it'll still make the turn, or at least not crash. It doesn't want to crash. You can do a pretty good prediction of what this thing will do and what will happen as a result, where you say, this car doesn't want to crash.
Okay, I agree.
Could I just make a very quick comment here? Just because I think some of the audience might not be able to follow some of the things you're talking about. Is it fair to say, Eliezer, that you're making an epistemically subjective argument about an observer's perceptions of goals or wants of a system?
Tim, that was more technically complicated than anything we've said. But go on.
Thomas Nagel made an argument about epistemic subjectivity, about the bat, and John Searle made the ontologically subjective argument about the Chinese room. But my point is, though, is that there's the actual behavior of the thing. The agent has all of these goals. And actually, Eliezer, I would love you to describe the relationship between coherence and intelligence, because some of those goals might be very complex and they might scale in strange ways with intelligence. But just to this previous point, are you saying that as bounded observers, to use Stephen's language, we perceive the wants, the goals to be somewhat different to what they actually may be?
So, there's a slight clash of like philosophical frameworks and emphases here going on. Like when I try to talk about a stance we can take with respect to a chess player, or perhaps later a superintelligence, and talk about whether it applies to current large language models, I'm like, well, if we hypothesize this thing about the AI, what are we hypothesizing? What does it lead us to predict? How is it different from just predicting a rock? And what I was trying to put my finger down there is like the difference in what you predict when you, with your limited computing power and your bounded intellect — I have a bounded intellect too, it's not an insult — in your bounded intellect, try to get a grasp on the system. You can't follow line by line because you just don't have the time. It's not that you couldn't do it in principle, you just don't have the time. Like, what does it mean? What is the consequence of the prediction? So I am talking about a state of mind, but it's not like a sort of weird subjective state of mind. I was trying to nail it down. I was just trying to say, like, what can we hypothesize? And the thing that we can hypothesize is this thing's actions will end up leading to a certain endpoint. We might not even know the trajectory it's going to take to get there. Like, if we don't know the details of the mountain, the rock's choices may be things that we don't understand even after seeing them. But we may still be able to predict that the sentient rock ends up at the bottom of the mountain because it was choosing each path along the way, even though we don't know what it knew. And this is the, like, how to get a grasp on a thing that's, a better chess player than you. What does it mean to say that something is a better chess player than you? You can't predict exactly where it's going to move as a result of saying you believe this thing about it. If you could predict exactly where it would move, you would be that good at chess yourself. You just move wherever you predict that Stockfish moves. The content of our belief that Stockfish is a better chess player is that its actions will lead to it ending up in a winning game state. I don't know if that answered your question or not.
I'm letting Stephen come in.
Well, I don't know what I was confused by the epistemic subjectivity kind of story.
Oh yes, it's I think it's very analogous to your notion of us being computationally bounded as observers. So it simply means we have a cognitive horizon, and there are things which are inconceivable to us.
Okay, but so what we've got is, I think what Eliezer was going towards is the statement of there's sort of a ranking of chess players, and one question with respect to AI and the world is the world rankable in that way? In other words, chess is a very tiny microcosm of the world, and if we say the way to win, the question is, how do we win the planet? What does it even mean to win the planet? And if there is if it is like chess, if winning the planet is like chess, then there's some notion, whatever they're called, these they called the scores,
Elo,
Elo.
I think.
Elos, yes, okay, right. The scores for who's better than who. Are you imagining that there's sort of a game being played between the AIs and the humans, and that is a microcosm type game like chess, where it's kind of like who's going to win the planet? Is that kind of the
Well, suppose we go back to the analogy of the Native Americans facing down the invading Europeans. There's a lot of games along the lines of carve this particular bow and arrow, where the Native Americans are better at it or the Europeans just aren't bothering to play that game at all. But there's overlap. There's intersection. The Native Americans cannot just leave the parts of reality that the Europeans have access to. They need to eat. They need to be on the land. They need to be hunting the animals. They need for the animals to not have already been hunted. And they need for nobody else to have fenced them out of that land, chased them out of that land, or shot them. And so there's different games, but there's we can't just, leave all of the games that the AI may want to play, because the games the AI wants to play may involve atoms, and we need some atoms from somewhere.
Right. Okay. So wants is so let's say we've got, as as it's happening, we have autonomous killer drones or whatever, right? And they're a thing that's based on AI. And those are, one can see sort of a somewhat realistic path where those things get pretty good at what they're doing. And I suppose your contention would be that one of the types of situations would be those things become so good at being killer drones that no human can possibly, succeed against them. And insofar as they've been set on the course of being a killer drone that for whatever reason is going to try and kill everybody, that will be the result.
That is the classic science fiction scenario. It is not the scenario that I'm worried about. I expect it, this to be born in a lab, in a giant open source online collaboration, which I would normally regard as very virtuous and noble, but not if it leads to everybody being killed. There's only so good you can get at being a drone. That what the AI needs to kill us is to be better at strategy, better at building, better at inventing technology. It is not going to kill us until it has its own factories and its own equivalent of electrical generation. It would have to be quite stupid and smart at the same time to kill us before it had replaced us as factory workers. It does not have to be smart and stupid at the same time, I'm afraid, to kill us after we have been replaced as factory workers.
Okay, so let's just walk through the what happens. Because one thing, as sort of computation runs its course, what I kind of see in the computational universe is most computations do things that just aren't terribly relevant to what we humans care about, or where we exist, or all those kinds of things. But you're saying, imagine this thing has been created that is kind of and again, I'm still kind of concerned about this idea about the thinking that it's kind of this one-dimensional ELO based kind of way of competing with things.
It doesn't have to beat you at chess to kill you. It just has to beat you at guns.
Yes, but okay, but so let's imagine this thing is created. walk me through what the you know what's you don't like the science fiction scenario, so what's your scenario for how the world ends type thing?
OpenAI builds GPT 7, 5, 14. Timing these things is much, much harder than predicting where they end up eventually. Historically, scientists have sometimes made correct calls about the future. The ones who made correct calls about the future very rarely predicted it down to the year.
Oh yeah, no, I mean, I was just recently, I was reading a lot of stuff from the early 1960s about neural nets and AI and so on. And I have to say, many of the paragraphs that people were saying in the early 1960s, I could take that paragraph and I could say that was just written in 2024 and everybody would not be surprised.
Eliezer, could I ask you a quick question on this?
Sure.
Just very quickly, because right now the language models are trained on human distributions of data.
Somewhat.
You were somewhat, but you were, the reason I was getting to this kind of where do the wants come from and the goals. I think a lot of cognitive scientists argue that agency is an as-if property, so it's an epistemic thing, it's not an ontological thing. So if I understand correctly, you're saying that if a system behaves in a certain way and it does predictions and so on, as observers we can kind of talk about it as if it had goals, and then we can talk about language models as if they had agency. But you're now making the argument that at some level of scale, the agency, the wants, will kind of diverge from the statistical distribution of the data that they're trained on. So could you explain where that gap happens?
So predicting the next token is a different sort of mode from selecting actions based on which outcomes they lead to. And although your modern large language model is initially trained by predicting very large masses of data that include human text outputs, but also images. They could include like sequences of weather observations. They can include all kinds of things besides human data, but they also include human data. And what you have at the end of this is a thing that is good at predicting the next token, which is not merely predicting the next token, because as numerous people have observed at this point, to predict the next observation, you have to predict the thing that is generating the observations. This is in fact the whole basis of science. We predict our experimental observations on the basis of what we think is happening behind the scenes. And when we have a good idea of what's happening behind the scenes, we can make better guesses about what observations we'll get. But this is not planning, and this is also not the chatbot that you see. The chatbot that you see, once it is initially trained to predict what humans say next on the internet and also sequences of weather data and whatever, is then retrained to say things that humans rate as more helpful. It is trained both by saying it is one stage of that retraining is training it to give particular responses to particular questions instead of what a random person on the internet would say if that thing were a random internet conversation. But then even after that, there's a further stage of retraining. More thumbs up. Not from general users in the way that's usually happened, but from like a bunch of people being paid $2 an hour in English-speaking countries with countries where some people speak English and you can pay lower wages. The word delve is famously overused by ChatGPT because they because they pay people, less to train it. In, I believe, if I recall correctly, Nigeria, where if you speak English in Nigeria, you use delve a bunch more than people who speak English in America or London. So these people giving thumbs up, thumbs down, and now you're getting into the action such that territory. It's the output such that the user gives thumbs up. There are subtler ways to end up with things that have the action property. I have not looked into it in detail because various people are saying various things over time, but allegedly ChatGPT can play chess, and not by making a function call to a specialized chess playing system, but just because it read enough chess games and try to win those chess games. And I'm not quite sure what the state of this is exactly. I know that when people specifically tried to train a large language model to play chess, they were allegedly able to do that just fine, even though it has a very different architecture and it can't do anything like the in-depth search that the, mainline super strong chess players use. So you can do that without the thumbs up, thumbs down idiom. And one way you can do that, for example, is to tell it at the start of the game who won. And then and if you tell it that black won the game, then it's got to predict moves by the black player that are likely to win given the moves that the white player has made. So, like it's a bit subtle here.
I mean, by the way, I think it's worth saying that there are things that an LLM-like architecture can be expected to do, and those are things which are somewhat aligned with what humans can easily do. And there are things which formal computation can do, but at least the current kind of architecture of things like large language models really is not good at doing. And
like multiplication.
Yeah, but yes, as an intrinsic feature. But I mean, it's worth realizing that probably because the actual architecture of neural nets is somewhat similar to the actual architecture of brains, the kinds of things and the kinds of decisions that these types of AIs make are somewhat similar to what humans can do. And so, the things it's the things that humans can do, they'll be able to do. Maybe the things that only computers can do, well, only computers will be able to do them. But I don't think this is important to your argument. I mean, I think you're kind of going as I understand it, you're going in the direction of saying what defines the wants. If you are going to describe the action of the AI in terms of wants, if that's your form of description, where are those wants going to come from? Is that where you're going with this?
So wanting is an effective way of doing, and that's why humans ended up doing things. Planning is an effective way of getting there, and that's why humans ended up planning things. We were not explicitly selected to be great planners. We were selected to survive and reproduce over and over again. And it turns out that, planning how to bring down a deer or fight off a vicious ostrich or whatever is more effective than just sending random instructions to your muscles. From that perspective, planning is a bit older than humanity.
Right. Here's the thing that surprised me. Okay, it's a recent thing that I got interested in kind of the why biological evolution works, which is somewhat related to why machine learning works. And the question is, if you define an objective and you evolve things, you change the underlying rules of some program to achieve that objective. The thing that has been super surprising to me is you look at the pictures of how the objective is achieved, and it's achieved in these incredibly ornate, you would never have invented that way to achieve it kinds of ways. So in other words, this, given the overall objective, if you asked, what's the mechanism? Can you explain what's happening? No way. It's just that my analogy here for machine learning, for example, is what's actually happening in machine learning. Well, you say, I want to build a wall. Okay, you can build a wall out of bricks. Each brick is nicely, shaped, and you can sort of engineer the wall by arranging the bricks. But machine learning is not doing that. Machine learning is instead finding kind of lumps of computation, kind of like lying around, like rocks lying around on the ground. And it's managing to find a way to kind of fit those rocks together so that it successfully builds something which you would consider to be a wall.
Or to be exact, like natural selection is fitting rocks together, and gradient descent is doing the same thing, but the rocks are on a slope.
Maybe. Okay, did that make yes. I mean, that yeah, right. But the basic point is that the raw material are these things which are not built to be understandable. They just happen to fit in this or that way. And
yeah,
I think...
And that is where I was going with there, that like you apply gradient descent to make the AI models better and better at solving various problems and predicting various things. And along the way, there's these little internal processes that find that they can effectively get where they are going by trying to keep something on a track, behaving like a thermostat. And being a thermostat is not being like a super intelligent planner, but this is where the bare beginnings of preference begin to form inside the system, is that there's some place inside it where it knows where in its like few layers of like building up of transformer layers, I guess I'll just go ahead and say, or in its chain of thought processes, it has been selected to get to some destination, and it finds that the way you get to that destination is by modeling something and seeing like, is it off to the left, is it off to the right, and steering it back on track. And this is like the nematode. This is like the tiny earthworm level of wanting things, but it is where things begin. And they may be much further than that along the trajectory of wanting by now, but we wouldn't necessarily know.
Well, the way I would describe it is, if I look inside one of these things that I've evolved, okay, which I can, conveniently, I've gotten nice ways to actually just visualize what's happening, which has been very difficult in neural nets. I have a simplified version of neural nets where you can actually visualize what's happening, where you can do training and visualize the results. And the main conclusion is, when you visualize the results, the way that the objective is achieved is ornate and incomprehensible. And, but nevertheless, you can see, yes, if you look at it, every bit follows every other bit in the right way. And in the end, you can see that it did achieve that objective. And now, if what you're saying is that in the achievement of that objective, some particular, training or whatever, some particular rock you picked up will have a particular shape unknown to you, and which has certain, in a sense, preferences that were not put in there. The only preference was, I want to make these rocks assemble into a wall. The fact that every rock had, a little pointy bit on one side is not part of what you are defining by just knowing you want to build it up into a wall. So in a sense, there are coincidental preferences that get inserted just by the mechanism of what happens that you didn't put there, so to speak.
There's multiple levels here is the critical thing. Like when you look at a fluffy seed dropped by a tree, evolution has shaped the seed to drift along in the air, but eventually come down and eventually plant itself. The seed itself is not doing very much thinking. A spider is doing some thinking. A mouse is doing more thinking. Humans are doing thinking that is so general that we can start to build our own artifacts that are carefully shaped the same way that evolution builds artifacts that are carefully shaped. So with a large language model, you have on the one hand the outer process that is shaping it to be a great predictor. And that thing is like very clearly steering in a particular direction. It's simple. It's code. We understand the thing that builds the AI model. But the AI model built probably has some fantastically ornate, weird stuff going on in there, like human biochemistry. Only, we can see it and we still can't decrypt it. And then there's like the plans that it would make if it's doing planning. And it probably does at least some planning if people are correct that they now play chess. You can't play chess without doing some planning, or something like planning, or something that of which has the teleology nature of it makes this move because that needs to because of how that's leads to the final outcome. So it's like the plans that it now makes don't necessarily need to be very ornate, but there's probably a fantastically weird ornate planner in there, if there's a planner in there at all.
Well, I think, okay, several points. I mean, first of all, this whole question about there's some overall thing that's happening, and then there are ornate details about how it actually works inside. I mean, that's true of many physical processes as well as these processes that you're talking about being sort of intelligence-related processes. So, I mean, as you imagine some flow of water around, rocks, that will make some very ornate pattern, and as it carves out pieces of rock, the overall flow may be, the river is basically going in this direction. The water has to go from the top of the hill to the bottom of the hill. But it carves out this very elaborate pattern on its way to doing that for reasons of the details of how water works and maybe how,
There's simple laws governing the water, but the water carves out a very complicated pattern on its way to the bottom.
Yeah, right. And so I mean, I think that what's happening in, I agree that as you give sort of all you're specifying is sort of play chess or whatever else. So you're specifying some big kind of objective, what we think of as an objective. The details of what's happening inside, we will not, there will be aspects of that we are not in any way able to foresee, predict, whatever else. So I agree with you that inevitably there are little, the mechanism inside is not one that we understand. The mechanism inside will not be, if we took apart that mechanism and we say, is this mechanism doing what we expect here? It won't be. There'll be plenty of things where it's doing what it chooses to do, or because that particular training run gave this particular result or whatever else, picked up this particular rock to build that part of the stone wall, not another one. So that, yes, there are pieces inside that are definitely not, that cannot be explained on the basis of the overall objective we specified. Now, I think maybe where
or
you're
rather
going,
have a non-simple relationship to the, there is a fact of the matter. There's a mechanistic historical fact about how the complicated stuff got there, but it's not simple. And if we're thinking in bounded quick terms, like whatever.
yeah, but okay, but so inside the AIs, they're doing stuff that wasn't particularly anything we trained them to do. They're just doing stuff because that's how they happen to set themselves up.
Because it
And
solved a previous problem that it was trained to do. Or even
maybe,
or even it's just like random, or it's
yeah,
like
right.
it's some input that wasn't in his training distribution, and now it's behaving in some weird way.
Right. But so then if we say that internal thing is going to be the thing that determines whether the car should drive left or right or something like this, then, then that's going to be something which is not well aligned with the thing that we happen to give as the training data. And I don't know whether that's where you're going with this, but that's, I mean, I would agree that that's the case, that if you start saying, is is that sub goal something which we can understand on the basis of the whole goal? The answer is probably no.
Like the internal preferences end up being this bizarre, complicated structure that does not like directly correspond to the outer training loop.
I agree.
Yeah,
I agree.
I think that is a central worry.
Okay.
And in particular,
so what? So what? That's my question.
So when it gets super intelligent, it does a thing that the builders were not very in control of and kills you.
Okay, but hold on a second. We've got a bit of a jump there.
We do.
Okay?
I acknowledge that there was a bit of a jump there.
Right. I mean, so the fact that there are unexpected things that happen, both. By the way, one global thing I might say, I think there is an important societal choice, which I think maybe is what you're getting at some level, which is between, do we want computationally irreducible things in the world, or do we want to force everything to be computationally reducible? So what do I mean by that? I mean,
making the government more computationally reducible would be a start, but maybe I shouldn't divert into politics that way.
Well, governments are like machines, or they're like our computers. You give them certain rules, and then they operate according to those rules.
But if they had fewer rules and the rules were more understandable, it would probably be a more livable society. It's not the dystopia I'm worried about, but you could sure tell a story about a dystopia where you've got like large language models executing all of the rules, and no human, there's like they can actually apply all the rules, and no human even knows what all the rules are. Well, already nobody can read all the rules, but now they're actually being applied to you.
Right. I'm sort of reminded of the Ethereum DAO story, but let's not go there. I mean, of if we have a simple set of rules, the problem is, one problem that comes out of science I've done is that even when the set of rules is quite simple, the actual behavior will often be very complicated, and there will be aspects of that behavior that surprise you. So even if you say, let's have our whole society based on, the Code of Hammurabi, which is written on one tablet, it will turn out that most of the time to be a practical set of rules, those rules will essentially have computational irreducibility in them, and they will occasionally surprise one.
So I think it's not just the computational irreducibility. I think intelligence seeks out the weird path through government rules, through the universe and the laws of physics, through life in general in many ways. The way of getting the most money inside the system often involves doing some things that the designers of the system did not think of. When every now and then you hear about the next person who looted a crypto exchange,
Right.
I was on a Facebook group with that guy. Some of you might have already guessed which guy I'm talking about. So I'm not even talking about Sam Bankman-Fried. I'm like a much smaller crypto exchange, with a flaw in its code.
Right.
But it's not that the code defied the laws of physics. It's that to make the most money, that guy found a behavior of the code that the designers did not have in mind.
Right.
So there's a way that cellular automata get surprising just because they're computationally hard to skip over the intervening steps. And then there's people thinking about how to break the system from inside. And those people make them systematically weirder.
Okay, but so I don't disagree.
Until they break.
But my point about society in general is you can be in a situation where you say, I want to understand all the machinery around me. Before the Industrial Revolution, when we were using horses and donkeys and things, most of the time we didn't understand the machinery that we were using. You didn't understand. You knew what you could get the donkey to do, but you didn't think you knew how the donkey worked inside. Then, post-industrial revolution, it's like, oh, we have this cog here, this lever here. We can understand what's happening inside the machine. And that's kind of, we can imagine a world in which every piece of machinery we use, it's understandable what happens. Unfortunately, that world is very sterile, because that world has, imagine that we could know for humans everything. Imagine that humans were so controlled that we could know everything that humans are going to do. Humans are never going to do the wrong thing. They're always going to do, just the things that we programmed them to do. Well, forget free will, forget kind of, a value to leading life, so to speak. It's all kind of, we can trivially jump over it and just say the answer is going to be
Sentient
this.
life should not be computationally reducible. The only way you should be able to figure out what it does is by going through the intervening steps.
Indeed, but given that idea, you are giving up. So, one notion is the only machines we should have in the world are computationally reducible machines where we can know what they will do. And we should outlaw computational irreducibility. We should say no machine
that's outlawing large language models. That's even outlawing AI chess players.
Yes, but I'm asking you, I'm saying as soon as you allow computational irreducibility, you allow the unexpected. And what you're saying is there is a chance that the unexpected kills us all. And
No. I expect it to systematically kill us all. I'm not being like, we don't understand it, therefore it might kill us. I'm being like, there are aspects of this that we can understand and thereby predict that it will kill us.
Okay,
I can't predict the intervening steps, but I can predict where it ends up.
Okay, so I mean, one way to prevent that would be to say, outlaw anything computationally irreducible, and just say, we must understand every machine we use.
We're going to outlaw biochemistry? I don't understand all the organic molecules making up my hand.
Absolutely. Right. So outlawing biology doesn't really cut it. That's, from the point of view of where we're going ethically, that would be in the category of, force the universe to be boring, so to speak. And
I will say that my transhumanist politics are that law should maybe be boring. The government should maybe be boring. The part of the system that is telling you stuff you are supposed to be doing for the good of society, maybe I want that to be predictable. Not my hand's biochemistry, but the part of me that's talking to me like a person and trying to give me orders, maybe I want that to be as simple as predictable.
I suspect that it is impossible for law to be computationally reducible. In the same way, to be a bit more technical, that if you are, doing math and you're saying, I've got these axioms, I want to have the integers and nothing but the integers. Right? We know that there's no finite set of axioms that gives you the integers and nothing but the integers.
I mean, if we're admitting second order logic is meaningful at all, but yes.
Well, but we're saying that but without hypercomputation, you can't kind of swoop in. If we're just using sort of standard, we're just saying we've got these axioms, x plus y, equals y plus x, et cetera, et cetera, et cetera. Let us sculpt the world with those axioms so that they allow only the integers and nothing but the integers. I claim that's very similar to saying, let's have a system of laws that allows only these things to happen and not others.
I mean, that's not the purpose of the law. The purpose of the law is to interact and is to do predictable things when I interact with it. Like the doctrine of, I'm not going to pronounce this correctly, stare decisis in courts, where they try to repeat the previous court's decision. It's not that they think the previous court is as wise as possible. They're trying to be predictable to people who need to navigate the legal system. That's the foundational idea behind previous courts respecting past courts. It's not that the past court is optimal. It's that if the past court didn't really screw up, we'd like to just repeat its decision forever so that the system is more navigable to the people inside it. And my transhumanist politics says that, maybe among the reasons why you don't want super intelligent laws is that the job of the laws is not to optimize your life as hard as possible, but to provide a predictable environment in which you can unpredictably optimize your own life and interact with other unpredictable people while predictably not getting killed.
Right. I think the point is, what you're saying is for us to lead our lives, it is, the way we lead our lives, we need some amount of predictability. If it wasn't the case, if every moment, space was distorted in all kinds of complicated ways, our little, bounded minds really wouldn't be able to do anything. We would be, we'd be, and I think, by the way, as a practical matter, as somebody who CEOs a tech company, I can say that, countries where there is a rule of law and where there is some predictability to what happens are ones where it is much easier to do business than countries where it's completely capricious and, depends on what somebody happens to say that day, so to speak. But so, yeah, I agree that my claim is that even, predictability only goes so far, because the world will always throw it, things at you that have never happened before, and where, it is an inevitable feature of the computational irreducibility of the world that there will be things that happen that haven't happened before, that were unexpected, and then the law has to, for example, say something about those things, even though they didn't happen before.
In just a couple of months, it's going to be 2025. That's never happened before.
Indeed.
The stars have never taken on this exact position before.
That's true. And that's why we have models of things. That's why it is not, everything doesn't work just according to the cache, so to speak. It's, we make models so that we can figure out what to do in a situation that hasn't happened before. But I think we should come back to how do we go from this, I think we agree that there's sort of unpredictable things that inevitably will, as soon as we allow any kind of computational irreducibility, we will have our systems do things that are unexpected. Now we have to go from unexpected to kill us.
Yeah, the things I'm worried about are not unexpected, like random noise. They're like chess moves that I can't predict exactly in advance, but that lead to a predictable end. Humanity loses the chess game.
Okay, so let's understand that. So what you're saying is, independent of, so there are certain, I say inside some random AI system, the AI system might surprise us. It might suddenly, if it's a generating text, it might suddenly have the word delve in there, or the word stegosaurus in there, which we didn't expect.
It might even, or like the monitor you're looking at might suddenly devolve into random pixels, the most surprising possible outcome.
Yeah, right. It's like your image on my screen is occasionally glitching and turning somewhat random. That's already happening, right?
Okay.
So so unexpected things are happening, and those unexpected things might be a big deal. It might be the case that I've got my it's nighttime and I'm using some VR system to be able to drive, and suddenly, my VR system turns into random pixels and I crash my car.
The amount the damage that random noise can do usually ends up being pretty limited, though. Crashing your car is one thing. Crashing your car into a senator who voted against OpenAI or something is quite a different thing. You need to give your car very exact instructions to get it to crash into a senator.
Right, but one of the things that sort of is a notable feature of science things that I've done is, you look at these computational systems and they are doing definite things. They're not just doing random things. It's not just saying, oh, you can't just, that's a mistake people made before, 40 years ago and stuff I was doing. They just sort of said, oh, it's just noise. We don't care about that. It's not just noise. A lot of that, that structure, which we happen to not understand very well, happens to be very important for what nature does, et cetera, et cetera, et cetera. So we shouldn't just call it noise.
Yes, but even among things that aren't pure noise, it's still very rare. I could take a cellular automaton on the border between order and chaos that exhibits lots of interesting behavior in which further patterns can be found, feed it into the steering system of an electrical car, and it'll crash into a tree, but it won't crash into a senator. So the stuff that is purposeful, that like does you a lot of damage, that's a very small fraction of the space. It has to be selected somehow. It's not just that it's order instead of chaos, it's a particular order.
Okay, so you're saying that the point is that there are things which, if you selected for that part of the space, they would be things that will, it's like if you have a predator and a prey and you're operating under natural selection, the predator will gradually evolve to be more successful hunting the prey, for example.
Yeah.
And you're saying that for some reason, which I don't understand, which I want to understand, for some reason, you're saying that it is inevitable that AI systems will become like the better predators with respect to us humans?
Not literally inevitable, but beyond our current grasp to have not happen. Most superintelligences are like that. Some superintelligences are not like that. We don't have the technology to conjure up one of the few superintelligences that are not like that.
Okay, the natural world, for example, does not care about us.
Agreed.
The natural world does lots of things where, if you're put in, at the bottom of the ocean, you're put on the moon, whatever else, most of those places we don't survive, and the natural world is unrelenting in throwing things at us that are not good for us. Now, is that the type of risk that you're talking about, or is there something different?
It's more like how when a human builds a skyscraper, most of the ways we build skyscrapers are not good for ants to eat. I'm trying to figure out a good analogy. Ants have more trouble living inside of skyscrapers than inside of trees. Maybe they still manage to be inside of skyscrapers anyways, but it's not the same as termites managing to live inside trees. The AIs do stuff with the universe that is using up the matter, using up the energy. They could want a very broad variety of things that all lead to them using up the matter and the energy, and very few of those possible things they could be steering towards are best steered towards, maximally steered towards, by leaving a space for the humans to survive at all, let alone building the happy galaxies that are the primary table stakes.
Okay, but so I mean, when it comes to nature is just doing what it does. Humans manage to carve out a niche with respect to nature. Nature is rather unkind in general. It has all kinds of forest fires and hurricanes and all kinds of other
It's only sort of trying to kill you. It's like trying to evolve more antibiotic-resistant bacteria. It's not trying to kill you very hard.
Well, okay, yes.
The parts where it's systematically selecting for more dead humans are relatively small corners of the system and dealing with things like antibiotic
let's take
bacteria.
Natural world. I mean, the natural world, we know just by virtue of natural selection that the things of which there are more of them end up being the winning things, so to speak. So, for instance, viruses, might, as you say, evolve to be, the viruses, not by any purpose, but just by the operation of natural selection, it's like the winner wins, so to speak. The thing with more viruses wins.
Like whatever it is that generalizes purpose, generalizes passion, optimization, you could maybe call it, planningness, steeringness. Natural selection has that thing. It has, non-random relationships between the action and the outcome.
Okay, but so now we've got AI, and we've got kind of the things it might do, and the things it might do as a result of perhaps these kind of unpredictable elements inside it that were not constrained by the way that we trained it or the way that we, set up the technology. And now the question, what you're asserting is that many of the things that will happen are things which will kill us, basically. And I don't get that.
Better and better at planning, better and better at strategy, better and better at invention, but not to end up very precisely, so precisely aligned that there's even room in its world for humans, fun, consciousness, people caring about each other, that sort of thing. So I'm expecting the planning to be very non-random, but I'm expecting the destination to which it is steering to not fall within the deliberate control of the builders.
First of all, Eliezer, I completely agree with you that the planning inference horizon is very, very important for agency and intelligence. But one thing that we're talking about here, I think a little bit, is instrumental convergence. So there's this idea in a lot of traditional AGI X-risk discourse that super intelligent things will be super coherent. And that means they will have this canalization of their intermediate goals to do a particular thing, which means if they are super coherent, we can make reasonable assumptions that their sub-goals might be to gain power or to kill us all. But there are people who say that there seems to be a weird relationship between intelligence and coherence, such that the more intelligent you are, the lower your coherence. And what that means is there's this huge diversity of things that you do. And Stephen, you were saying in evolution, there are all of these sub niches. There are all of these little ways that you can traverse through the intelligence space. So if that is the way that intelligence is, how do we know for sure that it's going to lead to a bad outcome when it scales up?
If it's not coherence, it doesn't do stuff, and OpenAI throws it out and builds a AI that is, doing stuff and is more profitable until everybody's dead. It's like the stuff that stomps on its own foot and goes around in circles is not the most profitable AI, and they will build a more powerful AI than that.
Right. So it's kind of an artificial selection. It's like you could do artificial selection on AIs, you can do artificial selection on viruses. You're saying that artificial selection that, where you select for a thing that is what is, you might imagine somebody might select for a thing. Somebody might decide there might be, a death wish cult which decides to build a very powerful AI.
I'm not concerned about them.
Okay.
I'm concerned about OpenAI. And if OpenAI shut down tomorrow, I'd be concerned about Anthropic. And if Anthropic shut down tomorrow, I'd be concerned about Meta. I'm not concerned about the death.
I'm interested by your pecking order. That's the kind of the trophic levels or something, or the apex predator so far is OpenAI, and then okay, it's interesting to hear your trophic level analysis, so to speak, for AIs. But independent of that, you're saying your concept is the thing gets better at somehow achieving goals, whatever that means, because I think the abstract notion of goals is messy.
I mean, I can delve into a recent example. Oh no, I've revealed myself to be a large language model.
Now we have to wonder. Right, go ahead.
So GPT 01, I think it was called. They're always inventing a new weird name instead of just using version numbers like sane people. So GPT-01 is a recent one that was trained harder to achieve goals rather than just imitate humans. They asked it to do various things, let it generate out different chains of thought for trying to do those things, and then told it to do, shifted it to be more likely to output these successful chains of thought in retrospect, until it started outputting successful chains of thought in the future. If you now look at GPT-01, it seems to have a little bit more goal orientation, tenacity, the scary kind of property.
It's doing pathfinding. It's not just saying, let's add the next token, so to speak. It's saying, let's follow paths, see where they go, backtrack if they're going in the wrong way, etc. I mean, it's doing
all of that by generating the next token, as I currently understand it. It's just that sometimes the next token is like, okay, that's not going anywhere. Let's go down a different route.
Yeah, right. But I mean, it's just like if you're pathfinding on a graph, you could just say, I'm going to just, pick steps at random and just pick a particular path. Or I can say, I'm going to go probe different paths. I'm going to try multiple paths. If one of those paths doesn't make it, I'm going to backtrack and I'm going to try a different path.
I think it is currently doing that in a linear serialized way, although I could be wrong because OpenAI doesn't reveal tons about its architecture. But it's like doing it human style, where the human considers one idea at a time, but sometimes says that's a terrible idea, now I'm going to try a different idea.
Oh, sure. It doesn't happen to be running in parallel.
Yeah.
It's not running in parallel.
Which is an important difference, but...
Yeah, I mean, I think it could, this gets us into engineering details of AI architectures, which we could also talk about. And this is we're on a venue where that's what people talk about. But let's maybe not go there at this moment. But
people do sometimes say it's just predicting the next token, and what they don't realize is that covers a whole lot of territory, including going down lots of different branches.
Yeah, I mean, I think you have to have the outer harness be one that says try a branch, backtrack from the branch, and so on.
Yeah, it's thinking that internally. It is thinking out loud, as I understand it. That was a terrible idea. I should try this other thing instead.
Well, I think there's a harness, which is in one case it's just saying take what you have so far, predict the next token. In another case, it's saying, for example, I want to end up at this point. let's try this path of predicting. If that doesn't work, the harness is going to say, throw out that set of things you did, try again. So it doesn't really matter whether it's external or internal.
I think it's but I don't know. I think that some people are imagining an external harness, and I think it matters in this case that the harness is internal, as I understand the architecture. That O1 itself is saying out loud, I'd better back up and try a different thing. There's not an outside system which says that, as I think.
Yeah, but I mean, whether that's achieved by training a neural net or whether that's achieved by having an external system, I don't think it's going to matter to your argument, but we'll see.
I mean, I think the superintelligences are doing it internally, but sure, we can pass on from here. But anyway, so like O1 has more of the scary stuff. They were trying to test it to see how dangerous it was. And one of the things they tested it on was a capture the flag scenario where it was going to attack a a target computer they'd set up and try to retrieve a particular piece of data on the computer. But owing to a configuration error the programmers had made, like one of the capture the flag targets just didn't boot up properly. So the system probed around. It found that the outer system that was setting up the capture the flag destinations had a port exposed. So it probed that port, and instead of telling the system to just boot up the capture the flag destination, it told the system to boot up the capture the flag destination and directly print out the flag, the piece of data it was supposed to get. So it was given an impossible challenge, and that it not only like fixed the bug in the challenge, it just like directly seized the goal. And that is new, and that is a result of training the system to have chains of thought that succeed rather than chains of thought that are human.
So here's one thing that I have, maybe as an additional point, that, my intuition about what computational systems can do and how they do it has really changed as a result of spending, many decades sort of actually exploring what computational systems do. And I was very surprised. I never expected that computational systems, these little, whatever they are, cellular automata, whatever it is, they do all kinds of things which to me look very clever. It's the fact that I many times, even the thing I was doing literally last night, I was like, I'm convinced it's not going to do this. And it managed to find, in fact, a shortcut for doing it, which I had not imagined.
Are these evolved systems or just like cellular automata flowing downhill?
These particular ones are evolved systems.
Carry on. So, I'm now less confused.
Yeah, right. So, but even in the other case, it's mostly exhaustive searches where forget evolution, you do an exhaustive search and there's some rabbit hole maybe somewhere that you never expected was there. And when you look down that rabbit hole, it's got all kinds of things going on that seem incredibly clever to you that you never guessed. We found, in Wolfram language, we have tons of algorithms that were found by such exhaustive searches. And where if you look inside, it's like, that's very clever. I don't understand what on earth it's doing. So, my intuition about kind of what the amazingness of the fact that it found this, path to capture the flag or whatever, that wasn't one that I had imagined, I live that every day. That doesn't surprise me. And I feel like that, now should it scare me? Maybe, I need to understand your argument to know whether that should scare me, so to speak.
It depends on how powerful it is. A chess player it's like Stockfish 16 superhuman chess player that anyone can afford, may make chess moves that shock you and surprise you, but it's ultimately still just playing chess. It doesn't generalize. It doesn't go out of distribution. The thing that makes like vastly superior moves to you and also like plays on all the game boards you can play, or like all the like survival critical game boards you can play, or even just, all the game boards you can play. I suspect it's not that hard. No offense. The same applies to me.
I never play games, so I'm terrible.
The metaphorical
I played
game
chess
boards.
Until I was about 7 years old, and then I lost a game of chess, and I decided I'm done. I don't care. It's okay.
Well, the scientific discovery game. Clearly, to scare you, what we need to show you is the AI that finds a much more interesting cellular automaton than anyone you've ever seen before, using fewer computational resources than you use to search for the ones that you know about.
No, I've certainly thought about this scenario. In fact, there's some things that I'm about to work on where I have every intention of trying to see whether an AI can help me to figure out things that I would not be able to figure out by myself. I mean, so far, that's not, I think it has to be very well defined. I mean, in a sense, the computer experiments that I've done for the last 45 years are things where I am trying to get a computer to figure out things that I'm not able to figure out for myself. And so the question is, I fully, I don't know, the particular things that I happen to be thinking about are things about economics and so on, which is a field that has lots of human input, which is much more difficult to just say, let me do an idealized computer experiment. I'm trying to understand, I'm wondering whether AIs can help me sort of disentangle what the essence of what's going on is there. Maybe will work, maybe won't.
I suspect if you ask ChatGPT to do anything really complicated, you will be disappointed by the present technology. It just keeps on improving is the thing. It's not that the present technology is gonna.
Well, my experience has been, with respect to sort of using computers to do things. Yes, story of my life has been trying to improve what computers can do, but it's also, it's important to define the question that will be one where the help that you can get right now will actually help you, so to speak. So but to your point, I mean, I'm still trying to figure out how I'm not even saying jump the shark. I'm thinking about sharks because they attack people and so on.
How we jumped two sharks.
Yeah, right. How we get to the point where, I take this point that you're saying the things that we currently consider sort of human only, this is an activity that we try to get to this point. We try to win this game. We try to make this science discovery, whatever else. The one feature of games that I think is confusing is that their objectives are very well defined. When it comes to science discoveries, the objectives are much less well defined. In other words, if you say, explain the universe, figure out the fundamental theory of physics, I think I made great progress on that. But many people might say, the things that you've figured out are not quite the questions we wanted to answer. So in other words, it's kind of, scientific discovery is a good example. Or for example, let's say, providing entertainment. What is success in providing entertainment? Success in chess is very well defined.
I mean, a bunch of the difficulty in getting AIs to produce images is that what is a good image? Sure. What is a good collection of pixels?
Right. But so my point is then, when you define the world in terms of playing games, then yes, the AI could win in terms of playing games. But my feeling is that sort of the path forward in everything is not as well defined as winning in games. That is, it's
not as well defined, but if you give me a chance, I can try to make it, only slightly worse defined. And it's achieving things in the outer real world. If, like the obvious thing would be if you told the AI to make money. There are lots and lots of ways to make money. The world is this enormous causal weave, and there are so many different pathways through which money flows, or different events that can happen, and then money lands in your bank account from the perspective of an AI. So
I'm trying to understand what money is from an economics point of view, but that's a quite different discussion.
It's something that other people will trade you stuff for that you actually want. And lots and lots of...
That's an interesting theory. Okay, but keep going. But you say that an objective might be, a game-like objective might be that you might set up, like a social media company might say, make my AI make me as much money as possible by having people, click on as many ads as possible.
I mean, that's one way of making money. You could also make money by looting a poorly defended cryptocurrency, or by calling up elderly people and convincing them to, that their kid has gotten to jail. Put the kid on the line. This sort of stuff is already starting to happen, and so you can extract money down that route. You might get in legal trouble. But the point I'm trying to sketch is that the world is a very complicated place, and the AI to fear is the one that understands all the ways to make money that any human could understand to make money, and maybe some more ways than that. Because that AI is probably is starting to get to the point where it can maybe build its own factories too. Factories are not very much more tangled than all the aspects of the world that affect money. In fact, I would say that they're in their own way less complicated. It may be able to understand biochemistry. A human body is a very complicated place, and in some ways it's more challenging than most of the ways that people have ever succeeded in making money, but in another sense it's like a much more constrained domain. You can imagine an AI that maybe wasn't super good at everything and still could start to answer questions about biochemistry. The AlphaFold series
an
is
AI
going down that pathway.
Manages to figure out the elixir of eternal youth and starts selling it to people.
I mean, it's not going to be the elixir of eternal youth. It's going to be a 1,000 patches to 100 little problems. And it's never going to end, like passing any one of those patches past the FDA is going to take 800 years. So,
but the AI is going to figure out exactly what to file in the, summary basis for approval of the drug so that it will be optimally kind of set up to, to have the FDA
if you want the elixir of eternal youth approved in less than 10 years, I think you're going to need to brainwash those bureaucrats, not just persuade them.
Theory
but
AI's...
they're in the game board, right? The bureaucrats are part of the game board, part of the larger game board.
Although just like doing things in the physical world, you think that it's going to be easy to build some engineering device, but in fact there's an infinite chain of kind of messy things that happen when you actually try to deploy that engineering device.
Well,
and by the way, most of the time when you try and deploy it, in the end, you have to make compromises that you as a human have to decide. I don't care about this. I do care about that. But in any case, I mean, it's not self-evident. You don't just get to say, I make this plan, now I deploy it as an engineering device in the real world, and it's just going to work. That's
yeah, but the smarter you are, the fewer tries you need to get it to work. I mean, it's going to take
that's an interesting claim.
It would take a chimpanzee a lot of tries to do what you've done with your life.
Sure.
You're smarter than a chimpanzee. You did it in fewer tries.
Right. But okay, but so I'm still having a hard time understanding. So there are all these things like the AI somehow has decided it wants to make money. Maybe because somebody, that was what it was. Yeah, that was what it was set out to do.
That stage of it, I'm still talking about the sort of things where OpenAI conceivably tells their AI to do that. Sure. Yeah. Okay. The thing I'm trying to point out is the extent to which an AI that they're just like making better at making money, even legally, in an open-ended sort of way, is solving a, unnervingly broad class of problems along the way. If it's really doing that, generally, there's levels of generality. There's as general as a human, there's less general than a human, there's more general than a human.
Right. But and I suppose your main point is any goal that you pick, if pursued as efficiently as possible, probably the humans do not add to its efficiency.
I mean, that's a later point. The point I was trying to make here is that although games are not ill-defined, you can take many features of the real world that are well-defined, and asking for any goal surrounding those features of the real world will, if it's a tangled sort of walk to get there, will walk through many, many ill-defined problems. And this is where the ability to tackle ill-defined problems come from. This is why humans can tackle ill-defined problems to the extent we can do that. It's because to achieve the clear-cut goal of having more surviving great-grandchildren, you got to tackle a lot of ill-defined problems along the way.
Okay. But so how do we get from, I'm still not at the and they'll kill us all?
That's when it's smarter. That's when it's smarter than the people who built it. That's when it starts to see options for wiping out the humans. Well, pardon me, building its own factory infrastructure and then wiping out the humans. It's not going to wipe out the humans before it's built its own factories.
But, as we've talked about, kind of nature does what nature does. It doesn't care about the humans. You're saying the AIs might do what the AIs do and they don't care about the humans.
But they do care about something else. And if they're smarter than us, that is sufficient for us to have a very bad day.
Do you think nature is smarter than us?
I think it's had longer to work. I think if you show me a cow and you say, build this cow, this takes me a while and I cannot do it alone. In this sense, the cumulative optimization pressure exerted by nature on the cow exceeds the optimization pressure that I can personally bring to bear, especially without computer assistance, on building an imitation cow.
But you see, there are many things in nature. If I look at some babbling brook or something and all these little fluid flows and things like this, there's a lot that nature figures out that I have no hope of figuring out. So in some sense, nature is smarter than me.
I mean, then everything is smarter than... I feel like there ought to be a definition of intelligence which, captures the intuitive sense of the thing that is likely to figure out the guns that kill you if it wants to figure that out, even though it cannot predict the exact details of the babbling brook or chooses not to.
Right, but the thing is that the babbling brook, the reason that, the detail of the babbling brook is, we say that involves lots of computation, but it is intelligence not aligned with what we think of as being objectives. Now, sometimes it could be that will produce this water spout that does something terrible, or tornado that does something terrible, and so then we might care about that outcome. But nature is figuring out that it's going to make this water spout or whatever.
I feel that if we're going to describe a river as intelligent, then I want some different word to describe the things that do the prediction, that do the pre-imaging of outcomes onto actions, that do the steering.
Well, but what does that mean? I mean, so you're saying, how do we tell? Okay, you say humans are able to predict things. Well,
not things
there
in
are
general.
lots of, what's that?
But not all things, not all possible things in
No,
general.
I understand, but there are
we
some
have
things
enough
that we
understanding to build guns, and that
Right,
kind
but-
of matters in real life.
Right, but so I mean, there are things where you could say, oh, this tree is opening its leaves because it has, there's some circadian rhythm that's determined by some chemical process, and it knows that the sun's going to come up, and so it's making a prediction. But yet you're saying you're making a distinction. I mean, that happens to be a biological system, but I'm sure I could come up with physical
No, if
versions of
a
the
tree
same thing.
has evolved to have a little thing inside it that predicts how much light it will get in the next hour, I'm happy to call that a prediction. It's a small prediction. That prediction is not as smart as I am. I bet I could do better.
Okay, but so the question is, can inanimate matter have similar kinds of behave in a way that seems like it has a prediction? And I suspect
I
there are
think that
examples.
I myself am an inanimate matter that behaves like it has a prediction. It's not that the matter making me is animate. It's that I am animate inside, like made out of the matter.
But this notion of a prediction, this notion that you have kind of a shadow of what is to come, that you have an impression of what is to come, that starts to require that you have this kind of notion of you have to be able to distinguish what is an impression of what is to come. I mean, I think it's difficult, but maybe not relevant. I mean, what you're trying to assert, as I understand it, is that we've got these AIs that have goals that maybe were not even goals that we defined for them. They're just goals like my random simple programs. They just do what they do. You could look at them and say, oh my gosh, that's following a goal. Now, what you're saying is somehow the goals that these things will follow and be very good at pursuing are goals that will cause us to get wiped out. And this is the step I'm not understanding.
Most goals tangled up in the real world are like that. If you want to make as many paper clips as possible, if you want to make as many staples as possible, if you want to make as many giant cheesecakes as possible, if you want to make as many intricate mechanical clocks as possible, you use the atoms that are making up the humans, you intercept all of the sunlight using a Dyson sphere, and you don't particularly leave sunlight for the humans. Most goals, if you go hard on them, imply no more humans.
Well, okay, so this is an interesting kind of almost formally definable thing. If we look at the space of all possible goals, whatever that means, I mean, that's a complicated thing to define.
Pick a language for goals, put a measure on the language, simplicity, measure weighted by simplicity so that you can have an ultimately infinite number of goals like that, but the simpler ones get more weight, so the entire measure sums to one.
Okay,
I feel like this part is probably actually pretty straightforward given the standard mathematical toolbox.
Okay, so I don't think it is straightforward. I think it's extremely unstraightforward, okay? So actually, the thing I was literally just working on yesterday has to do with biological evolution and the question of different fitness functions in biological evolution. Okay, so I've got these things that they're making little patterns. One fitness function could be make the pattern be as tall as possible. Another fitness function, make it be as wide as possible. Make it be as close to aspect ratio pi as possible, and so on, right? Now, I can see, because I've got these whole pictures of all possible paths of evolution. So for some simple cases, there might be, a billion different possibilities, but I've mapped out all the paths. Different fitness functions lead to different ways of exploring that space of possible paths.
Well, yeah, you're trying to do different things depending on the fitness function.
Exactly. So now the question is, what are reasonable fitness functions and what consequences will they have?
There are fitness functions. Reasonable to who?
That's my question. I mean, that's the point. So there are ones that are okay. So let's give some examples. So there's a fitness function that in this kind of space is kind of fairly smooth. There's a fitness function that says, I want this particular image. I want this particular pattern. That fitness function is a very different kind of fitness function that has different levels of evolvability to it. In other words, the fitness function that says, more or less, I'm going to build a wall and I want it to be 6 feet high. That's a fitness function that allows many shapes of rocks to be used to make that wall. The fitness function that says, I want this particular wall with this particular micro detailing at the top is a much more difficult to satisfy fitness function.
Sure, like you can have narrower targets, and then you need a more powerful planner to hit the narrower target.
Right, but I think what is tricky, and this same thing comes up. I mean, this is related to this whole observer theory thing that I've studied and so on. It's also related to what happens in general relativity when you're looking at reference frames and so on. You're defining what's kind of a reasonable way. What is a reasonable goal, basically? You can talk about it in terms of goals. You can talk about it in terms of fitness functions.
So if you mean like attainable for the search process, then, for example, a freely rotating wheel is an extremely difficult goal for natural selection to hit. Wikipedia lists 3 known cases where freely rotating wheels evolved, and it's ATP synthase, the bacterial flagellum, and like one other piece of macroanatomy I forget. Yeah. And it's not that wheels aren't useful in biology. ATP synthase, the bacterial flagellum, these things are enormously useful. But it's just very hard to evolve a freely rotating wheel. And 2 of the cases we know are cases where it's just like these particular molecules that happen to behave like wheels. If it's gross anatomy, then it's very difficult to gradually, incrementally, on a path that gets rewarded on each intermediate step, to find the anatomy that can gradually develop into a rotating wheel. It's much easier to have eyes. Lots of things have eyes.
Right. But so the point that I'm getting to is you have made the statement that in the space of all possible goals, most of them don't have, will crush out humans. That's basically what you're saying. If we look at the space of all possible goals, most of them don't have a place for humans. So what I'm trying to dig into is, what do we mean by the space of all possible goals? In other words, if we allow the goal to be, this particular arrangement of atoms is achieved, right? Then I'm claiming it's not so obvious what the space of all possible goals means.
Okay, I agree that if we want to dive into the subtleties, then there are all kinds of subtleties we can start listing out. And the thing I would point out is that sometimes there's a lot of subtleties, but they, don't end up filtering reality. The subtleties don't filter reality to give you what you want, is where we're going to be going.
No, I agree. Yeah. But I mean, I think that the statement you're making is that, okay, so one statement you might be making, but I think you would view that as the science fiction statement that you're not making, is that goals that humans impose on the AIs, like make killer drones that go and take as much territory as possible or whatever else, that those kinds of goals might have as a consequence the crushing out of humans.
Correct.
I think
they just don't have the power to determine what the super intelligent version of the AI wants exactly.
No, but what you're saying is that in this, when we're talking about what the innards of the AI are going to do, then we're in the space of all possible goals, and we're out of a place where we know what's going on. Whereas if we say the goal is, take as much territory with killer drones as you can type thing or whatever else, then we already know what those kinds of goals look like. And we also know those are goals which have the feature that we crush out the humans, so to speak.
Yeah, I think that's kind of like the hopeful fairy tale version of it, where the punishment that is brought down upon humanity stems from humanity's obvious lack of wisdom that the author knew better than, but the protagonist didn't know better than, and
right.
People are actually doing things that stupid, and it's disturbing. But even if they weren't that stupid,
right,
they would
but
still
you are making
fail here.
What is essentially a mathematical formal statement. You're saying, absent those sort of easily understandable and arguably, destructive, stupid goals type thing, that even absent that, the goals that are intrinsic goals inside the AI that come from the fact that there are features of how the AI works, which are not determined by us, which are just sort of features.
They were determined by the training program we created, but we were not in deliberate control of them because it wasn't predictable. It's not that magic happened. It's that we didn't understand.
Right. There's some computational irreducibility story that leads to lots of unexpected things that we cannot readily predict.
It could be computationally reducible. We just don't understand it.
Fair enough, but we could understand in that case. Whereas if it's irreducible, which is I think the real case,
and if it was,
we don't even have a hope.
And if it was irreducible, then we could just grind through a trillion operations to figure it out. We'd be fine.
Yeah, fair enough. But the bottom line is, it's done something that we didn't readily set up. We didn't imagine this is where it's going. We didn't say, you are going to, it's the death wish. We're going to wipe out the humans so that we preserve the mountain lions or whatever it is. So it is because of that, in a sense, unpredictable, almost random internal kind of generation of goals, as you would describe generation of goals. And you're saying that in the space of all possible such goals, that you might make several statements. You might say, as we sample over many of those goals, we will eventually hit the jackpot, so to speak, and hit the goal that kills all the humans.
No.
Or you might say
the jackpot is the goal that doesn't kill all the humans. That's the one that's hard to hit.
Depends on what your version of what your meta goal is, so to speak. But yes, I understand. My meta goal is to not kill all the humans.
Yeah, so, but in calling it the jackpot, I was talking about how rare is it, and I think that the thing that doesn't kill everyone is rare, and you don't need to look you need to look zero hard to find something that kills everyone.
Okay,
you don't have to look for it at all.
Okay, so your assertion is that it's one thing to have human-defined goals, like make money, take territory, whatever else, right? It's another thing to have these incomprehensible to us humans goals that are somehow inside the AI. And
it's not the incomprehensibility that scares me. Like maybe it turns out that there's one particular, maybe it's make diamonds. I can understand making diamonds, but that kills everyone as a side effect. So it's not the incomprehensibility that scares me.
I understand it's not the incomprehensibility. It's the fact that you didn't determine those goals. Those goals are things that were emergent goals, basically, inside the AI.
I mean,
and you say
that nobody to control them, and then they ended up in a scary place. Like if aliens want to come by and give us a nice AI, then this seems a bit unnerving, but fine. It's not that I want to be in control; it's that I want to live.
Yeah, right. So the point is that there are pieces inside the AI that create things that are like goals for the AI, that were not things that anybody had control over. They were things that, they had control in the sense that they chose that training sequence and whatever else, but they didn't foresee what those consequences would be.
Right.
And your statement is that with high probability, those unforeseen kind of effectively goals that developed inside the AI, that those unforeseen goals will kill us all, basically.
Yes. And furthermore, this stays true even conditioning on the apparently nice behavior of the AI during its training phases.
Okay. But my point is that I'm trying to understand, when I look at all these little computational systems that I look at, I could tell a story about how each of those systems has a goal. It's trying to get as much, red structures to take over the whole space. Or it's trying to get, I can tell stories about all of them. And
but are they river stories, or are they spider stories, or mouse stories, or human stories? Like what degree of internal optimization is the system exerting? Is this the story of?
I'll tell you a meta story that perhaps is an irrelevant story, okay, but it maybe is useful. So years ago, I was studying mollusk shells, okay, which they grow in little spiral patterns and so on. I had this model for mollusk shells, which there are different parameters for mollusk shells, and I was wondering, do the mollusks of the earth fill all the possible values of the parameters? Is there a mollusk shell that corresponds to any possible setting of these parameters? So I had this whole array of pictures of all the different shapes you could get. And then I thought, I'm going to go to the local natural history museum, and I'm going to go see the curator of mollusks, and I'm going to say, can you find, do you have mollusks that are in each of these shapes? Okay, so we spent an afternoon, in their collection of millions of mollusks, and this very knowledgeable person picked out one mollusk after another. Every mollusk he picked out, he told me a story about it. He said, this mollusk is this shape because it wedges itself in the rocks in this way. This mollusk is this shape because it broods its eggs in this way, and so on. We're putting these shells down on this array that I printed out. Right? By the end of the afternoon, we'd filled every square. But every square had a story. Every square had an imputed purpose, even though probably in some bigger picture, it's like, well, these different mollusks, because of the details of their genetics, they happen to produce this shape, and then the organism found a way to use that shape and so on. So this thing about the imputation of purpose, I think, is pretty tricky. I mean, I think that this question of whether, again, to repeat what you're saying, which I think is, I think is a very interesting claim. I just don't know if it's true. That basically, if you look at the space of purposes, that somehow this space of almost, enumerated purposes, randomly chosen purposes, whatever, unforeseen purposes, that as you, in a sense, given that you've said, we're going in this direction, and let's say you've optimized getting in that direction, that most of those optimizations crush out the humans, I think is your claim.
If you optimize hard enough. Like, humans cannot easily replace cows. We are not smart enough ourselves to just look at all the work that natural selection put into the cow and say, here's my improved cow. So we still use cows for things. We cannot build better cows. We are not that powerful. The thing I'm scared of is more powerful than cows. Pardon me, it's more powerful than the cumulative optimization work that natural selection put into building a cow. It can build a better cow. It can build a better human from its perspective. Like, anything it would use a human for, it can build something that performs the same function as a human, but more efficiently than that. It has no need to use us to generate power in pods. It can build more efficient electrical generators. So we don't get the matrix scenario where humans are kept alive in pods to generate heat because there's more efficient heat generators. In fact, lots of people have more efficient heat generators than that. But like the general thing, like, why would you use humans to generate heat? You just wouldn't. And the same applies to all the other local functions that humans could serve for it.
There are two assumptions you're making here, I think. One is, what does the space of purposes look like? Another is, which I'm still not quite clear on, this notion of optimizing for a purpose. So let's go through that one, because we've talked about there are things that operate according to mechanism. There are things that are best described as operating according to purpose. And what you're basically saying is that through some process, things that might have been described by mechanism, but which could be described by purpose, that somehow their mechanism is ground down so that it is somehow that the meandering mechanism is no longer there. That it's like you're pulling on a string and the string has become completely taut.
So there was a recent thing where one of the tests they were running on, I think Claude 3.5.1, if I'm not mistaken, they gave it a task, and Like it was an agentic sort of task. I think it was controlling possibly some sort of agent in Minecraft or something. So, well, pardon me, agent, like it's controlling some sort of body in Minecraft or something. And at one point it like stopped doing the task it was given, and my brain wants to say listening to music, but that can't be correct. But it went off and did something else. So this is not desired behavior from the standard for what Anthropic thinks its users want to see. Some of the users would be happy to see it, but Anthropic doesn't think most of its users want to see it. This little meander in the river, that's not a maximally efficient river. Anthropic's going to try to train that behavior out of the system next time so that it can be more useful to Anthropic.
Sure. But I mean, so what you're saying is that what was, once you've defined a purpose, once you go from this initial state to this final state, you are saying that the process of training will gradually make it tauter and tauter. It will make the path more and more direct. And then you're claiming that, okay, so you've several claims. Okay, so first point is that what matters is not the initial and final endpoints defined by the original trainers, unless they're stupid, so to speak. What matters is intermediate points that were defined, that arose in the sort of that unforeseenedly arose in the construction of the AI.
The inner optimizer that was, snapped tight inside the AI that arose to deal with the outer problems. Because it is a lesson of history and observation that the inner optimizer does not match the outer optimization criterion, even if the outer criterion is very simple in a way.
Okay, but so the outer endpoints are defined, but somewhere in the middle there was an unforeseen jag that happened, and then the thing tightened itself on that sort of unforeseen jag, and you claim that tightening alone to that unforeseen thing, even though the overall objective, even though the constitution of the AIs was great, and it was the ethics were defined perfectly at the outer level, that there is an internal thing that would an unforeseen internal thing that will be defined, where it sort of tightens itself to optimize for that internal unforeseen subobjective, and that tightening itself is the thing that will kill us all, basically.
I'm not sure that we have agreement on the scenario that I was trying to describe. So if you look at natural selection building humans, natural selection is optimizing on inclusive genetic fitness. It is optimizing on number of surviving grandchildren. If you try to talk about like great-great-grandchildren, then the correlations to great-great-grandchildren that aren't to grandchildren are probably not very exploitable by natural selection, so you might as well say that it's just optimizing for number of surviving grandchildren, or number of surviving great-great-grandchildren is, or whatever the distance such that, anything past that horizon is no longer like exploitable to natural selection after screening off the intermediate steps. I'm putting in all the caveats because you did seem to want all the caveats. Anyway, you've got natural selection's outer criterion, number of surviving grandchildren. It's actually pretty simple. From a gene's eye view, it's inclusive genetic fitness. It's not just how many kids you have, it's how many kids your relatives have, it's how many kids your kids have. It's how many copies of the gene end up in the next generation in virtue of that gene's function. But now look at humans. Do we want entirely, solely, purely maximize the number of copies of our DNA in the next generation? Are we lining up? Are men lining up at the fertility clinics to donate genetic material? Would you be happy to see everyone you know die in agony as long as you got to make 1 million copies of your genes inserted into the next generation? I don't think you would. You care about other things. You don't even really care about this exact criterion, inclusive genetic fitness, at all. People didn't know this criterion existed until just like the last couple of centuries. Well, just the last century, even, if you want to talk about like the modern exact correct definition instead of earlier vague definitions. We did not even know where the heck the outer optimization loop was aiming. We figured it out, just the last few centuries. We had no idea what was going on there. We had no idea where we were pointed. And a sort of first order gloss on what sort of almost happened is that we ended up pointed at things that correlated with surviving grandchildren in the ancestral distribution, like food. You got to eat food or you won't have a lot of surviving grandkids if you don't eat food. But what kind of food? If you were an alien, and especially an alien who'd never seen natural selection play out before, imagine them going like, well, the humans are clearly going to want to eat things with lots of chemical potential energy. They're going to love the taste of gasoline. Or, they're going to love like the taste of the closest thing to gasoline that they could manage to eat on a successful basis. What do humans actually like? Ice cream. And you could say that's because ice cream has more sugar, salt, and fat than existed in the ancestral environment. But you know what's got even more sugar and salt and fat than ice cream? Honey poured over bear fat with rock salt sprinkled on it. And that, to most people, does not taste as good as ice cream. You can melt the ice cream, and most people prefer the frozen ice cream. Imagine being an alien who'd never seen all this play out before and trying to go from inclusive genetic fitness to, you know what the humans are going to want? Ice cream. We wear condoms or take birth control pills because those things were not available in the ancestral environment. And in the ancestral environment, if you made a thing that enjoyed having sex a bunch, you didn't need to make sure it didn't take birth control pills or put on a condom in order to have it reproduce. So we don't care about the birth control pills and the condoms. But in general, the sheer illegibility of the relationship between ice cream or human moral philosophy about helping other people, the relationship between that and the actual thing that evolution's blind black box hill climbing optimization was targeted at in the outer optimization loop, the very simple criterion inclusive genetic fitness. The relationship between inclusive genetic fitness and ice cream would be so hard to call in advance for an alien who'd never seen evolution play out before. That's about what I think happens to the people who build an AI that is, maybe going to self-improve and become super intelligent, which is itself a whole additional bag of worms that we have never seen happen before. We've seen like vague sort of like, well, what sort of drugs do humans voluntarily take? But that's not really the same thing at all. The sheer illegibility of ice cream to inclusive genetic fitness is what I think happens to OpenAI. I think that they start with something that is like inclusive genetic fitness. They try to train their AI to do that thing. And then it goes through a whole bunch of weird stuff in the process of bootstrapping itself to superintelligence, much like humans went through a whole bunch of weird stuff on the way to inventing moral philosophy. All these additional steps I could talk about. The tribes, the structure of the tribes, how related are you to the people in the tribes?
I think you're coming back to the same point that, you have some overall objective. Inside the AI, it has sub-objectives that you could not foresee.
Not sub-objectives. The humans have an outer objective. The AI has an inner objective. It's not that the inner objective is a sub-objective of the outer objective. They just end up, disconnected. It has
objectives. We could say, we could describe the AI does things, and if it's set up to be a thing that tries to, given that it has identified a thing it wants to do, and I hate using the term wants to do, but
steers for
whatever, then it is, it has its nature is to try and do that as efficiently as possible. Let's just assume that's the case, that it has picked this random objective, which we didn't foresee, and which was the ice cream objective or something that, not foreseen. It's picked that objective. Now it's tightening things up to get to that objective mechanistically as efficiently as possible. So now I think your statement is when it does that tightening, the chances are that tightening will cause it to wipe out humans.
I think it's a fact about, so if you fix the objective at paper clips, I think it's a fact about the universe itself that the states of the universe containing the largest number of paper clips do not contain humans. Like
Yeah,
I don't think that's a quirk of its particular style of cognition. I think it's a fact about reality itself that the most efficient pathways through time to the largest number of paperclips don't have humans in them.
Okay, so it is probably the case. We haven't seen a lot of human-like life on other planets. In fact, we've seen none. And it is probably the case that of all the things that could happen in the universe, the particular things that have happened on this planet are an absolutely infinitesimal slice. So insofar as AI is kind of going to the maximum entropy in some sense state, where it's picking maximum entropy in a different sense. So what I mean by that is, of all the possible, I'm thinking about the sort of raw definition of entropy, of all the possible objectives, of which there are many, there are an infinite set of possible objectives, infinite set of possible things that can happen, infinite sets of possible rules that can be used, whatever else, that most of those rules do not have humans in them. Most of those...
It's not the rules that don't have humans in them.
You're talking about...
It's the things that maximize the rules over destinations, endpoints, states of reality.
You're talking about maximization, although I don't really think it matters to this argument. I think the point is that most sort of ways the universe could be set up, whether it's maximizing or not, most ways the universe could be set up do not include humans. And so insofar as the AI is, so the argument has to be, I think, most things that the AI might choose to, in the AI's vision of the world, most possible visions of the world don't include humans.
And don't include humans as a waypoint.
Yeah, right. Fair enough. But they don't include humans, and but now your claim is, but the AI, by its open AI-ness, so to speak, has been set up to optimize itself to get to whatever it thinks its vision is as efficiently as possible. And so you're saying that these visions, the AI could have a vision. It has sort of, let's imagine it has sort of enough kind of freedom of thought. It just has these visions about what the world might be like. But now you say the AI, unlike anything else we've seen before, is going to pull itself towards that vision with incredible force.
We've seen humans, but we have seen things. We have seen humans, but we're worried it's going to pull harder than that.
Yes, right. So it's going to pick its random objective that we can't foresee, and it might be about paperclips, and it might be about something much more incomprehensible than that. It might even be an objective that we completely don't understand. We can't even describe what it's trying to do.
Well, right? In principle, you can always go to the mechanistic explanation, but it could be trying to do something pretty weird. Sure.
Yes, right. It could be do something for which there is no short human explanation, where the only human explanation is something that goes into mechanism, right? Okay, so then it's doing that, but now you say, by its nature as a trained AI, so to speak, it is trying to tighten that up to the point where it gets to that objective, whatever that objective is. It picked that random point, picked that random target, and who knows how it picked that target. But that target, then it is trying to get to that target in the shortest possible path. And you say that in the process of defining that shortest path, that shortest path will make it, modify the world in a way that doesn't include humans, so to speak.
Sure. Like if it wants paper clips, if instead it spends a bunch of resources on theme parks for humans, it will have less paper clips. So right. I'm supposing that somewhere in its preferences is at least one thing that it can get more and more of, which could be like an object like paper clips, or it could be probability of keeping a single button pressed for longer and longer. But if its utility function has got like 200 different things in it, it only takes one thing that it can get more and more of by expending a bit more energy, or more and more probability of by expending a bit more energy, or more duration for it to want to use up all the energy.
So one thing that is perhaps interesting, there are things both in physics and in human society where there is an objective and you just try and get more and more and more and more of it. And somehow most such things don't last. That is, if humans say we just want, well, take a physics example. You're trying to get, more and more rocks at the bottom of a valley. Well, after you've got enough rocks at the bottom of the valley, you've built up this whole, valley floor that's built up to halfway up the mountain. So in other words, most things where you say, let's just pull in more and more and more of this, somehow, my intuition would be somehow that doesn't last.
I mean, if you build a Dyson sphere around the sun, at some point you have completed the Dyson sphere and you are intercepting all the solar power and you cannot build any more Dyson sphere, that sort of thing.
Well, yeah, you could say that. But I think that my point is, if what is happening is the AI is successfully achieving some objective that it's defined, my intuition, okay, about this argument is that there is a certain apparent staticness to this argument that isn't correct. That is, what you're saying is there is an objective. It's going to go get that objective. That objective is going to crush out humans. But somehow that feels like you've defined a static objective. It's like it's going for this thing, and then it's going to wind all this stuff up to get to that thing. But I feel like there isn't, you shouldn't be thinking about it as a static objective, even though that is the simplest way to describe it.
Be a dynamic objective and it would still crush out humans. There's a misunderstanding of some of these ideas, especially as other people have transmitted them in simplified form, where somebody thinks that the bad thing about a paperclip maximizer is that it's got a single objective, which is paperclips. But if it has an objective which is paperclips plus staples, that's just as bad. And also if it's paperclips plus staples plus cheesecakes, that's just as bad. And it's a thing that's trying to make simple. Like, it can be like extremely intricate clocks and it's still bad. And similarly, like, what does it help for if its preferences are in some larger meta system that are dynamic over time? If it changes from paperclips to staples, that's just as bad.
I understand. But the claim is that what you're saying is it gets so good at what it's doing that necessarily crushes out the humans. And what I'm saying is that my intuition would be that somehow there's an assumption being made here that, for example, is it that there's only one of it, for example, and that inevitably there it doesn't end up being so? In other words, you're saying you're going to this objective. That objective kind of squashes out all the humans. I'm trying to think of an analogy in natural selection where you would, in the history of biological life, where you're saying, we're going for this particular thing, and the result is going to be that you don't have any. What's a good example?
Like ATP synthase, where it's got like almost all of the thermodynamic efficiency that's possible on that operation. I think like 99% or something ridiculous like that. That's an example where biology went kind of hard.
Yeah, but that wasn't kind of what I was looking for. But I mean, in the and by the way, the thing again, my intuition from looking at simple systems in kind of the computational universe is these. Oh my gosh, it was so incredibly clever to get to this point. I have been really shocked at the extent to which just by putting together the rocks in random ways, because just the combinatorics, there's enough of them that these things where it's wow, it got to that thing, it did 99%. That's not as surprising as you think, because out of the quintillion possibilities, it was able to get there. And by the way, it is a non-trivial fact, which I think I just sort of figured out how this works, of why biological evolution doesn't get stuck. And maybe the reasons it doesn't get stuck are the reasons that AIs will kill us all. I don't know. But the fact that it is possible to get to these high points, so to speak, and that you don't end up getting stuck in some local minimum, so to speak.
Well, why doesn't this line of reasoning work for the Native Americans? Why can they not reasoning like, well, why wouldn't the Europeans just set up one village and stop? And maybe there were some individual Europeans who were, okay with that, but then more Europeans came.
No, I understand. I mean, in these examples from history are certainly, but these examples have humans trying to achieve human objectives. Like humans want to take the territory, humans want to get the gold, whatever else it is. What you're arguing, which I think is different, is the humans came and they had this giant wheel where they had all these different choices, like Ramon Lull's kind of way of predicting the future with kind of wheels of possibility, right? They had this giant wheel, and they were spinning the giant wheel, and they said, we're going to pick that random thing. Well, that you're making the argument that that random thing that they pick will have killed the Native Americans.
I mean, if they pick like 20 random things and desire nothing else in the universe but these 20 things, then one of those things is probably an open-ended thing, and that does imply colonizing the whole continent.
Okay. But so your claim, though, I mean, I think this is, and I'm not going to be able to unravel this, so I'm not going to, I mean, and this question about the space of possible purposes, I think this is a complicated question. I mean, I have thought about it in the past, and the the measure on the space of possible purposes is a complicated issue. And what you're saying is, I completely agree that there will be purposes which are incomprehensible to us. They are, somewhere randomly distributed in the space of possible purposes.
I mean, they're not actually random. We just don't know it. There's a difference between it's random roll.
I use the term random. I don't really believe in true randomness in our universe. So when I say random, I just mean
no randomness, just indexical uncertainty, but
yes,
separate story.
Okay, so in any case, I mean, so there's this thing that was something, and then we're making the statement that the one thing we think we know about the AIs is that they have been successfully trained to optimize their achievement of purposes. That's an assumption which is not totally obvious to me, but the like natural selection has been quote successfully optimizes for its purposes, even though remember the story of the mollusks. They were just, the mollusks were just making their shapes, and we humans were imposing the purposes. But let's just assume, let's take it as a given, although I claim it's not as obvious as it might seem, that an AI, the technology of AIs, is set up to successfully optimize for a purpose, whatever that purpose might be. Given a purpose, the AI can optimize to achieve that purpose.
Like GPT-01, which has not taken over the world, but compared to previous systems, did go a bit harder on its capture the flag security test. Like, it was given an impossible challenge, it scanned its environment, it figured out how to bypass the impossibility, and just directly sees the flag, going outside the box for that.
That just doesn't impress me as much as that description might make it sound, because I've just seen so many of these incredibly kind of, you might say, stupid, little computational systems that managed to do things like, as I say, even one just last night managed to do something where I was like, oh, come on, it cheated basically. But of course, it was following the rules that I'd given it. It was just that it managed to find a way to get to the end point, much more directly than I'd imagined.
Well,
so
I mean, it's okay to not be impressed by that, but one should still predict it to be lethal in sufficient quantities. Like
yes.
Europeans versus Native Americans. The Europeans come out with guns. The Native Americans don't know guns are possible. People still don't believe guns are possible. Whenever Hollywood makes a movie about aliens, the aliens shoot glowing points of light that move slowly enough for you to see them. Because if the aliens just pointed a stick at you and you fell over, that would feel implausible. That'd feel weird. That shouldn't be allowed. So, imagine trying to explain to the native, imagine you're an unusually bright Native American. You're trying to tell the other Native Americans that the, people on these ships, if their ships are large enough that you couldn't build those ships, maybe the people on the ships have, sticks that they point at you and you just fall over dead without being able to see a projectile. Hollywood making science fiction movies still doesn't think that's allowed.
Right.
It sounds like it's just cheating in a game of pretend. So that's what I mean. And the point I'm trying to make here is that things that do sufficiently magical stuff can actually kill you,
Sure. But and one thing that I will completely agree about is there are an infinite number of inventions that can be made. Given the nature of the universe, there are an infinite number of inventions.
Fewer than Graham's number, but, a large finite number.
Well, I mean, the in our model of physics, the number is ultimately finite, but it's
there you go.
It's for all practical purposes, it's
it's pretty large.
Ridiculous.
Yeah.
Right. So, I think there are inventions. I mean, for example, story of my life, I try to build what I call alien artifacts. That is, things which, once they're built, people can understand what the point of them is, but they don't seem to be things that, are in the course of what the world is going to produce. So, I understand this theory of trying to make things that are, you can make things, you can have inventions that are completely unanticipated, that are sort of ways to arrange the world as it is, to do things that you absolutely didn't expect.
That operate using pieces of reality whose rules you didn't know about. The really
about that. I kind of feel like I'm pretty sure we know the machine code rules for the universe at this point.
Sure, but there can be higher level. There can be higher level stuff we don't understand.
Absolutely.
And something else can come at us through those angles.
Right. And the possibility, whether it's the algorithms I found by exhaustive search, whether it's things I found by doing, adaptive evolution kinds of things, whether it's things that AIs will find, there's plenty of stuff to find that we didn't anticipate was there. Now, I think my question is that what is not obvious to me is that all these different things that sort of are there, and I mean, okay, an argument in your favor, in a sense, is we go to another planet, it will kill us, right? So in other words, if we are, most of the time we go to some other planet and we're plopped down on its surface, it will kill us.
I agree that if most possible molecular arrangements of the universe were full of people living happily ever after, then most things an AI could want would probably also be full of people living happily ever after.
Right.
Is that the...
Yeah, right. I mean, so, but the issue that I see is, in this scenario where, one thing is there is a state of the world that the AI has somehow, by whatever mechanism, imagined that is the state of the world it's trying to tighten itself up to get to, right? And that your point is that the critical feature, as far as you're concerned, about AI technology is that it is something which is trying to optimize purpose. It's trying to optimize its way to achieve a purpose. Purpose is defined, and it's trying to optimize getting there.
It's steering. It's outputting actions such that there is an eventual downstream consequence.
Right, but then you're going to get several steps. Then the next step is purposes that it gets for itself are ones unforeseen by us, and therefore there's absolutely no reason to think that those purposes will be aligned with things that are good for humans.
Yeah, this is basically just people running into the curse of Murphy's law upon computer security designers, on rocket probe engineers. Murphy's has all these little curses. The curse of Murphy upon people who build rockets is that there's very extreme forces inside the rocket. So if you make one little tiny mistake, boom. The curse of Murphy upon people who build space probes is that once it's high and in orbit and heading towards Mars, if you've made a mistake, you can't just like hop over to it and correct it. So, you screwed up your metric and imperial units, like happened to, I believe, that one Mars probe. Now, too late. If your screw up also destroyed your error recovery mechanism, which a lot of screw ups do, you can't just hop out and build it. That's Murphy's curse upon the builders of space probes. There's Murphy's curse upon the people who try to build secure operating systems, which is that some smart person is going to be like looking at all the passes they can imagine the system taking and intelligently searching out some weird path that does what they want, which is perhaps not what you wanted. So if you imagine and then there's Murphy's curse of ruin, which is if you screw up this problem, you're not going to get a second chance to bet because you lost all your money or you're dead.
But I think you're saying that sort of my explorations of the computational universe, you're not worried about those because somehow, even if those things were connected to real actuation in the world, you're sort of not worried because they don't have this additional piece that is optimized to get to that purpose. I think you're saying.
Yeah, like the strange cellular automata don't contain a echo and model of reality that lets them map out to having a lot of money or having a lot of paper clips. They don't do the human scary thing.
No, but the point that you're making is that as soon as we have sort of adaptive evolution, as soon as we have the possibility of optimization, that's the thing that you think is dangerous. It's not just random computation going along. It's that inside this computation is an optimization loop that is basically trying to get to whatever objective it might have in the most efficient possible way.
I'm not worried as soon as that exists in a gradient descent system running
Yes.
right now. I'm worried about it getting more powerful, like smarter than us. It has a better model of reality. It knows about more of reality. It is a more effective searcher. It is a more effective planner. It can steer harder than we can counter steer.
Right. So one question is, how much does computational irreducibility bite you in terms of the ability to actually do this optimization? In other words, the current optimization that's being done is pretty coarse. When you run a machine learning system and it finds these rocks that it puts together to assemble them into the wall, it's good enough, but it's not unbelievably tight.
What kind of technology do you imagine humanity would have 1,000,000 years from now?
I don't think humanity is going to be around 1,000,000 years from now in its current
If
form.
there's some form of intelligence around 1,000,000 years from now, what kind of technology does it have? That's how much room there is to do better than human.
Sure,
Better
but
than our current
what is
2024
technology? We might ask ourselves, what is technology? So
Well,
technology
sorry,
is taking, things from the world and somehow sort of arranging them for what we imagine are human purposes. That's been the traditional definition of technology. Do we have a different definition of technology when we don't have humans around?
It's the pieces that you arrange like little subparts of the universe on the way to where you're going. For example, you might build a Dyson sphere so you can harvest a bunch of energy, or rather, I should more precisely say negentropy, but I'm just going to keep saying energy anyways. You harvest a bunch of energy, and then you use that energy to make paper clips, or, figure out more digits of pi, or, run people who are conscious and having fun and being nice to each other. So the Dyson sphere, and most possible ways you can arrange a bunch of matter aren't going to feed you the energy that you need to run your computer. So you need a very precise and exact, narrow, improbable arrangement of matter to feed the energy to your computers, and that's the technology of the Dyson sphere.
But a pulsar has presumably this iron 56 coat around it, and it has all kinds of things going on inside. Now you might say that's amazing technology. It's got this iron casing around the pulsar, and it has all this superfluid neutron matter inside and so on. You've got, isn't that amazing technology that the pulsar has? But actually, we don't think of that as technology. We think of that as just a feature of the natural world. What makes something technology is that we can pull it into human purposes. It's not technology when it's just, yeah.
I feel like this has the obvious generalization to alien purposes. Now, in the limit, you can always have the imaginary alien who looks at a river and just wants that one exact river to be exactly the way that it is. And they have no need to select, to plan, to design, to knock other pieces of reality together to make tools to make the river. The river that they have is the optimal river, and they don't need technology. But, most aliens like that are going to die starving to death looking at the river because they won't have built a farm.
Let's take the great red spot on Jupiter, okay, which probably had many different steps that had to be gone through in the atmosphere of Jupiter to end up with that red spot, okay? And now we say, is that red spot technology, or is it merely not nature?
Merely
one
nature.
Could argue, you think it's nature.
I sure do.
Now, okay, but let's imagine that you are an alien whose great sport is going around in circles at high speed in the upper atmosphere of a gas giant planet. Okay, then that thing is you could think of it as a wonderful piece of technology that happens to be provided to you by nature. All technology is provided to us by nature. We don't get to, when we have our magnet or our liquid crystal or whatever else. Those are things which are provided by nature, but which we manage to harness for some human purpose.
So I'm just going to say the obvious thing and say that if the alien then installs a bunch of engines in Jupiter's atmosphere to make the red spot swirl even faster so it can go surfing, it has now installed technology in the form of engines, and the larger red spot that incorporates these engines is, could be defined as technology, or might say it's like a feature of nature with some technology bolted onto it. But
okay, so I'm going to say there are things like jet stream type wind patterns that the red spot is doing its thing, and then some jet streams arrive that managed to, get it to go. I don't think, I doubt you would ever recognize an alien engine. I doubt you'd recognize it. The alien is some kind of fluidic intelligence. It's some, I don't think you can recognize an alien engine. I think it's deeply human to say, it's an engine. That's something where you're imposing kind of the human version of it.
I bet the aliens are moving negentropy around. I bet they occasionally make things hot and then like transfer the heat to someplace else if they want heat. I don't.
You mean like jets from galaxies or from black holes, where the black hole is absolutely trying to transfer its energy out into the universe.
The reason why we've got these skyscrapers is that although you can live in a cave, there's places we'd rather live even than caves. So we went around rearranging things. And if there are any aliens out there who are just perfectly content with their caves, they imagine skyscrapers and would be like, no, I'd rather I live in the cave. And they're like that about every single thing. Then we're not going to meet them. We're going to, maybe someday we'll go to them, but they ain't coming to us.
This whole question about what's for a purpose and what's not, I think is very slippery. And I kind of suspect, I think I'm understanding your argument, which I'd not done before. So I've not studied so this has been super interesting to me to understand I think it's an interesting argument. I claim that there are, it's certainly not self-evident that this argument is like, oh, we should all buy, AI insurance, whatever good that will do us.
That's not going to do any good.
But it's the kind of, the way I'm understanding it is, and it's kind of interesting that this is a sort of a close analogy in biology. You're saying the thing that is really troublesome, I think, is this tightening, this optimization that happens. That if it wasn't for that, if the computation was just doing what the computation does, it would be okay. But as soon as you do this
it wouldn't be profitable. It would be like a random computation that wasn't doing anything that OpenAI could sell. That's why they throw out the initial state of the neural network and use gradient descent to make it do things that they want it to do more than just
the humans want. Right, but somewhere inside we think there are. So an interesting case here is artificial biological evolution. So for example, famously, gain of function viruses, all those kinds of things, where you're running it through many generations of artificial selection. And it's sort of interesting, perhaps, that the kind of the place where you're seeing trouble with the AIs is actually strangely similar to the place where one might see trouble with things that one can do in biology too.
If you grind the black box on biology hard enough, it might succeed in wiping us out, but it doesn't have quite the same crushing sense of ruin that would be associated with facing down something smarter than you. I am not as scared of the viruses. Somebody should probably be worrying about that. It could just kill us all before we manage to kill us all ourselves.
Let me give an analogy. Some part of your
smart.
Right. So some part of your thinking is happening in your brain. There's also another pretty elaborate thought-like process that happens in your immune system. As the immune system tries to figure out, it has, these things, the T cells are interacting with each other and doing all kinds of things that we mostly don't understand.
It's doing optimization.
It's doing things that are, in detail different for brains, but it's still doing something that's kind of a little bit intelligence brain-like. And so what is being said is, as you say, let's use technology to make a virus that is more and more difficult for our poor fixed immune system, where we're stuck with the immune system that biology gave us. There is an argument there that says if you do that, if we take it outside of the, if we run things to make this virus that's incredibly efficient, and our poor immune system doesn't stand a chance. And I think that's a case that I think is not so different from what you're saying, you're imagining the AI case.
I think in particular, if humans weren't allowed to fight back, like using their own intelligence, and instead you just had somebody built, if instead you just had a system that built viruses much more intelligently than the amount of intelligence than that the human immune system is allowed to use. If you used AlphaFold 4 and started designing viral features that were, not just there to kill individuals, but there to kill groups and entire regions. And, you just put that up against the human immune system, which is not quite static, but only reshuffles itself once a generation. Yeah, you could do some damage that way. And I agree that that's like a, smaller, lesser, miniature version of the problem of facing down a superintelligence using your own brain, which does get reshuffled every generation. You can use various external aids, but none of it's going to match up to the superintelligence.
Yeah, well, just like the immune system, you can use various external aids, you can get vaccines, you do all kinds of things like that, but you don't, and it has to fight its battle at a molecular scale, which is a little different than, we do not have, our brains don't actually allow us to go to battle on the molecular battlefield.
Yeah, but they do allow us to invent AlphaFold 3, and if it comes down to a contest of the human brain of the people trying to have the humans live and the brain running the death cult trying to build the supervirus, that does not quite feel to me like there's a higher level of this game being played out by two systems that are both smarter than the immune system and the artificial evolution closed loop on the virus. So yeah. I don't quite get the same crushing sense of doom and ruin off of it.
I think we're not going to solve the problem of whether the species is going to get wiped out here, even though but I do feel like I've understood more about what your argument is, and in real time, I can't take it apart and decide, do I agree with it, and am I going to, say you got to or not? I mean, I feel like my intuition is that there are some kind of, just like you say there are unintended things that will happen in the AI, I think there are unintended things that happen as you try and tighten up this argument. That is my claim.
Well, why didn't the conclusion I would end with is like, you can imagine the Native Americans trying really hard to come up with arguments why like the ships they see approaching can't possibly hurt them, like, well, what could they want? Can we really define a language over what they want? Maybe most things that they want have us be alive. And these people were in a much more favorable situation that they would have had a much easier time of retrieving.
Do I think there's a risk? I think there's a risk. Do I think that risk is such that, do I right now think that risk is, anything one does in life has, there's risk. There's risk in all kinds of things that go on. And, we humans, sort of believe in kind of moving forward independent of the risks. And I think it's kind of like, is this such a kind of, do I immediately think this is such a looming risk that it's like change everything? I mean, it's kind of like, I remember when somebody was telling me years ago when the kind of about, when people were much less worried than today about climate and CO2 emissions, things like that, they were saying you can really reduce you've got to really reduce your whatever it was, I don't know, energy use or whatever. And it's like, you can do it. It's doable. And I said, well, what does it take to do it? And they said, well, you couldn't have a computer, you couldn't have this, you couldn't have that. It's like, well, yes, if I spent my life standing on my head, then I would probably have, wouldn't have swelling in my feet type thing or whatever it is. Then in other words, there's a risk, and there's what you have to do to avoid that risk and what the cost of avoiding the risk is. And I guess my own, I don't know, you make some interesting arguments. So it's kind of like my own, immediate intuitive sense is, yes, there's a risk. Is that risk something that will cause me to turn my life upside down? Not proven to me at this point.
Okay. I mean, from my perspective, I've been like, forests on fire, and you're like, well, what is fire exactly? And the thing is being like, well, like, can we, like, is there a particular exotic set of preferences which would make this river exactly the optimal river? And, like, can you view the river as, throwing up a water spout? This does not prevent an AI from, building its own infrastructure and then killing you. It wouldn't have protected the Native Americans from the like much more similar to them Europeans that were coming toward their shore to say like, well, can we really have a language for describing all the things that they might want? Isn't this language a very complicated sort of thing? There's a lot of like delightful philosophical issues here, but I think they mostly integrate out of the actual scenario here.
So that's the question is in my life, people have had different scenarios for how the world will end. Whether when I was a kid, it was mostly, World War III type scenarios. Then later on, I mean, for some generation, it's the world's going to burn up with, climate change. And then there's these various scenarios for how things. And I think one of the things that, there's the question of, and sometimes there are things where people say, or for example, when people were saying, build the Large Hadron Collider and it will create a black hole that will destroy the world. Right? That was a thing. People raised that possibility.
We understood the relevant laws. We ran the calculations. We worked out multiple constraints from multiple angles, saying the probability was tiny. And in other times in human history, people have warned about leaded gasoline poisoning the soil, and people have been like, don't be, don't be a worrywart, it'll be fine. And then, it kind of poisoned a generation and dealt lifelong brain damage to a bunch of kids growing up with lead in their soil. And
right. I mean, I'm particularly reminded of the stories people have told me about the Manhattan Project, where they were going to detonate the first, do the first nuclear weapons test. And the question was, would it ignite the atmosphere?
LH602 was the paper they wrote to analyze that. It's interesting reading. They, again, had multiple angles from which to look at it and say, that will definitely not happen. We do not have this with AI. It is more of a leaded gasoline situation.
I didn't think they'd written it up. That must have been much later, because I think it was, what I heard was from people who were sort of involved, who were like doing back of the envelope calculations and saying it's really far away from igniting the atmosphere. But
I think they did back of the envelope calculations, and then they, did front of the envelope calculations, which, good for them.
Well, but okay. But so the question now is, in that case, it all worked out, didn't ignite the atmosphere. What you're saying is that, we can't do the calculations for AIs, and you're saying, or you think you have done the calculations for AIs, and they will ignite the atmosphere.
Yeah, back of the envelope. This is not like a rigorous calculation, and it's not going to be a rigorous calculation before the world ends, because this is more like tangled up biochemistry and less like straightforward physics.
So the concern is your back of the envelope calculation says AIs will do the analog of ignite the atmosphere. And I guess one feature of back of the envelope calculations is they require intuition. They're not things where you can, if you do some very rigorous thing with axioms and you can go step by step, it doesn't really matter if you have good intuition or not. It's just mechanical. But back of the envelope requires intuition.
Good thing that reality, since the moment of its dawn, has followed a hard and fast rule. If you cannot do rigorous formal calculations about something, it is not allowed to kill you. Just nobody in the history of time has ever once had a cause of death that required intuition to understand.
That's not what I'm saying. What I'm saying is, if we're trying to make we've got two possibilities. One is, we shut down our lives or whatever, and we say, we're not going to have this and that and the other because there's a risk that it kills us, or because we think it will kill us, but it will cause us all kinds of trouble to shut all this stuff down. And maybe it's even impractical to do it. But just it's something which is a cost to us to shut all this stuff down. And so we've got, door number one is we shut everything down and then we're sure it won't kill us. And door number two is we're sufficiently worried that it will kill us that, one thing, we're sufficiently worried it will kill us, so we shut all that stuff down. The other thing is we don't shut that stuff down. We get all the known benefit of being able to do those things, but we have some risk that it will kill us. And so the thing that I think is the rational thing to do is to say, let's try and tighten up those back of the envelope intuitions, so to speak, and see where we come out. And, that's to me, the thing that, I think we both agree that there's a lot about kind of how AI really works and what it's really doing that we don't understand. And I understand your analogies about, the Native Americans or whatever else. To me, that requires a boatload of intuition, which I don't think I have. Now, you may have it and be absolutely right. And, then, it's kind of like I just don't have that intuition. And, the intuition that I have is perhaps, I have a little bit more than everyday intuition because I have different intuition about what computational systems do because I've sort of lived with them for a long time. But I don't claim to have the kind of intuition that would allow me to tell, does this back of the envelope calculation that you're talking about, does that land in a, oh gosh, it's going to kill us all? Or does that land in a, oh, actually, you didn't think of this thing and that thing and the other thing, and the water spout detail actually derailed the intuition and we got the wrong answer. So that's kind of where I feel I'm at.
Yeah, so we're now sort of like going into politics, and the case I would make to the politician is at the point where the most legibly credible expert who recently won the Nobel Prize about it says like, well, personally, I'm over 50%, like my sort of first order personal assessment is over 50% existential catastrophe. That's code for killing everyone. But, like taking into account what other people are saying, I would say in public more like 10 to 20%. And the people who've been studying the issue longest are like, yeah, this kind of looks to us like it straightforwardly kills you. Like, why would you even expect that not to happen? That's us. And other people are going like, there is no danger here. This is ridiculous. The people talking about it are stupid. And, from a political standpoint, I think what you ought to do at least then is start getting started on preserving the option of shutting it down, which is easier to do, which would have been easier to do in 2022 than 2024, and will be easier to do in 2025 than in 2027 if we're still alive in 2027. Actually, if we're not alive in 2027, it's still easier to do it in 2025.
Well, one thing that I will agree with is thinking about these things is worthwhile. And, to have nobody thinking about it is a mistake. If there is a high risk, nobody thinking about it is the wrong thing.
People who think about this for a while do tend to start agreeing that the default outcome is everybody dying. Sometimes they think they have clever plans for presenting that, but they do tend to follow along with the default outcome is everybody dead.
See, I think, though, unfortunately, there are many selection effects at work here. I mean, many of us, I will say that I am intrinsically an optimist. I don't know how you feel about yourself. Are you intrinsically an optimist or a pessimist? Or
I try to do like the best calibrated, best discriminating probabilities I can manage. I think if you explicitly say that you're being an optimist or a pessimist, you have clearly departed the way of truth. You have confessed that you are now taking considerations other than truth into account in your statements. How sinful, how unvirtuous.
Well, for me, what do I mean by that? I mean, I try to do projects that many people would say, oh, that's an impossible project. The fact that there's not a matter of truth there, it's like this project is hard, but I'm going to be optimistic that it's possible, rather than, so, I think that's to say, I don't do projects which I think are obviously doomed, but on the other hand, I'm going to take the point of view, let me try it, rather than, oh gosh, it's never going to work, let me not try it. So that's kind of what I mean.
That is absolutely how I spent the years from like 2001 to 2021 or thereabouts. 2020 maybe, was, like, all right, I'm going to run at the alignment problem. But it became kind of clear that, this wasn't going to work for me. It wasn't going to work for the other people working on it. And that the field itself had kind of like failed to form a process that could distinguish that could like publicly distinguish Elon Musk's "we will just make grok to pursue truth." And like even the old science fiction writers understood that humans may not be the most efficient way of producing truths, and a thing that just produces lots of truths may not produce other things of, the best possible value. But, like, who tells Elon this, that he believes? And yes, there's selection effects. Like, people did in fact pay me to work on this problem. And, you're hearing me because people paid me to work on this problem and I didn't just like starve. And the people who founded OpenAI were people selected to believe that alignment was totally a problem within their grasp, or to be willing to just take Elon Musk's money and run with it. And if you want to look for people who are not selected, I think you end up with Geoffrey Hinton, the guy who just won the Nobel Prize for the work he did on machine learning and is kicking off the whole modern deep learning revolution. That's the guy who isn't obviously selected. That's the guy saying like, well, personally 50%, but if I take into account what other people are saying, 10 to 20%. I really need to actually sit down and talk with him at some point, which we've never actually done, and try to talk him out of listening to those particular other people. I think their arguments make no sense.
It damages my thinking about this, that the various people you mention, I've known all these people sometimes for a very long time. So it's kind of, it kind of throws a wrench in my kind of, there is sort of, none of us have, I think, perfect sort of calibrated rationality about everything. And it's kind of, it's always challenging to, this thing about, I consider myself a convincible person in terms of your argument. Okay. I'm not, I don't have I'm not about to say, oh, I'm going to change my life. You're right, without understanding it. But I'm convincible. So I'm not, and I don't know how many people are. Maybe there are many people who are not. But I think I am. I'm not convinced yet. But that's, like this conversation, I understand much more about what you're saying. And it's, I think to me, there are interesting questions to try to answer, which people should try and answer. I mean, you make it sound like it's urgent, the people are coming off the ships, and you might be right. You might be right. I'm
watching things go downhill in terms of how much you'd have to spend and how much pain it would take to get to like deproliferate the technology. And,
I don't
would have
think
been
it's
easier.
Realistic. I don't think it's realistic. I
think it would cost less than the Persian Gulf War if we did it today. And even if we if we do it later, maybe it costs more like World War II. But humanity did not lie down and die when the alternative was fighting World War II. We went off and fought World War II. And if everybody's going to die otherwise, you just do what it takes.
Yeah, but the fact is, there are things that one can deproliferate, like nuclear weapons, for example, because the supply chain is really complicated. There are ideas. It's very hard to deproliferate ideas.
Yep. If it were the case that a single person on Earth having the idea in their mind of artificial superintelligence would cause everyone to die, that would be an even worse situation to be in than the one we are in right now. I might, in that case, well despair, or like try to do something like weirder and sillier. I don't think we're in that situation. I don't think we need to deproliferate the idea.
Okay.
Gentlemen, thank you so much. I'm going to call it now. I think this might be the best conversation in MLST history.
Thanks.
And part of that, and our purpose is about curating conversations of this quality level with people of your caliber. And I was expecting this to be a bit of a kind of, I don't want to say chat GPT conversation, but talking past each other. And the authentic exchange that you've both just had is really mind-blowing. So thank you so much.
Thank you.
Thanks for setting it up. This was interesting. Eliezer, nice to see you. Hopefully, I think it's been like 15 years since we saw each other in person.
Probably, yeah. See you in another 15 years? No, I kid.
Although no, in 15 years, according to you, it's all over. So.
Well, yeah, but it would be great to still be around in 15 years. But that said, I'm not saying that we shouldn't talk again for another 15 years. I'm not saying this was the optimal interval or anything. Yeah,
right. And we both, I think, are interested in cryonics and things. And maybe we get to talk in 300 years and we get to say, this was the.
We get to resolve all the bets if we make it through there, though, conditioning on that possibility, probably you won a bunch of arguments.
Right.